Hello everyone. So today's video we are looking at mathematics paper 2, so paper 2 from May 2023. So let's get right into it. So obviously very important, make sure your calculator is in degree mode because this paper we do a lot of trig, so that's quite important, especially if you're doing further study maths. Make sure it's not in radians and make sure you round off to 1 decimal place unless otherwise specified. Okay, otherwise stated. Cool, let's get into it. So question 1 over here, they gives the data, the year marks out of 100 obtained by 8 pupils. So that's important in mathematics and physical science. So up here in this row is the math marks, down here is the physical science mark. Okay, so we have that, and there's obviously 8 students. They say use your calculator to determine the equation for the line of best fit in this form. Give your answer correct to 3 decimal places. Okay, 3 decimal places. Okay, so this one's quite easy. It's basically just calculator work. So if we switch to the calculator over here, so this is stats, so we're using mode 3. So we go mode over here 3 for stats, and it's the a plus bx version over there because we're going to have an X column and a Y column over here. So X column, Y column. So just be careful with that. So these are our X's, so they need to go in here. Okay. So we got 67, 77, 26, 99, 49, 38, 56, and 58. All right. So make sure that there's 8 pupils, so we need to be finishing in 8 over here. We need to make sure we have 8. Okay, so then let's move over to Y. We have 75, 83, 32, 94, 61, 44, 65, and 68, right? Okay, and again, it's 8 over there. Okay, so what we can do now is we can press AC. Now we press Shift and 1 because here it says stat. Okay, and we need to press 5 here for regression. Okay, so here's our A. Over there we can press 1 to get our A, and to 3 decimal places that'll be 14,533. Okay, so we're going to get Y is equal to 14,533 plus, and now what is B? So again, we go Shift 1, 5 for regression, 2 for B, and that is going to be 863. Okay, 0,863x. Okay, so that is that over there. So nice and easy first question of the exam for 3 marks. Okay, now they say calculate the correlation coefficient for the data. So this is R. Okay, essentially that's a very bad R. So it's R. Okay, so again, still calculator view over here. So again, we're still dealing with regression, so we go number 5, and you'll see number 3 is R, the correlation coefficient. And in this case, remember we need it to 1 decimal place. Okay, 1 decimal place. So what we can say is R is equal to 1. Okay, so R is equal to 1. So yeah, just this one. So just A needed 3 decimal places. Okay, just A needed 3 decimal places. So this one will still be 1 decimal place. So that one would be rounded to 1, okay? And then they say, what does the correlation coefficient suggest about the relationship between the mathematics year mark and the physical science year mark? So they're saying, what's the relationship between this and this, okay? And you can kind of see it if you look at the data. If someone performs poorly in maths, they're going to perform poorly in physical science, okay? That's what we can, and then vice versa. If they're doing well, 99 in math, 94 for physical science, okay? So it's quite a strong correlation. Okay, so over here for number 2, we can just say it's a very strong positive correlation. Okay, so you can just say it's strong, but you also need to say that it's positive. Okay, so it's a very strong positive correlation. Okay, so you get 2 marks for this question. You get a mark for saying that it's strong, and you get a mark for saying that it's positive. Okay, so don't mess that up, okay? Because here you can see, well, this is positive, and it's very close to 1, so it's strong, positive correlation. Okay, let's move over to C. They say that Kaya attained 70 for his math year mark. Use the model in A to predict his physical science year mark. Okay, so here's our model in A. All right, so he got 70 for math, so this is essentially his x. Okay, so x is equal to 70. Now we need to predict his physical science mark. Okay, because remember x over here is math mark. His math mark. Okay, so let's just take this to over here so we can just reference it. Okay, you don't actually have to write this. I'm just showing you how we're going to use it. So it's going to be 14 comma, I mean technically you could definitely write it. Okay, but yeah, so what you would have to show is this substitution at the very least. Okay, 0.863 70, we fill it in over there, and if we put this in the calculator, what we should be getting is, I'll show it in the calculator. If we look in the calculator, so I can go to comp now. So 14,53 plus 0.863 times 70. Okay, and I get 74,9. Okay, because remember we need everything to be one decimal place. 74,9. Okay, so that would be his Kaya's physical science year mark according to our model. Okay. And now they say comment on the accuracy of our prediction. All right, so you can say three things here. Okay, so firstly, let's have a look. Our x is 70. All right, so let's look at our data. And you can see our data goes from the minimum is 26 and the max is 99. Okay, so it goes from 26 to 99, the data. And we chose 70. Okay, so this is interpolation. Okay. So we can say that, well, we're doing interpolation. Okay, so this is one of the options. You can say we're doing interpolation is usually reliable. Okay, well, let's say fairly reliable. Interpolation is fairly reliable. Okay, it's not like we're doing extrapolation. Okay, so this is one thing you can say. So if you just say everything here in this line, you would get 2 marks. Okay, another option is you can say that R is equal to 1. So there's, so it's a strong correlation. So that's a strong correlation. So it's going to be reliable. Okay, so it's a strong correlation and our prediction will be reliable. Our prediction will be reliable. Okay, so you can say this, and then also for reliable, like that. Okay, and then number 3, well, you can just say 70 is not an outlier. Okay, so 70 is not an outlier. Okay, how would you know it's not an outlier? Because I'm reading off the memo here. 70 is not an outlier, hence a reliable prediction. So how would they know it's not an outlier? So normally when we do outliers, we do 1,5 times the interquartile range, right? We do Q1 minus this and Q3 plus. Okay, so I'm just going to write this for you. I would suggest the first one, to be honest. Interpolation, fairly reliable. But I'm going to write for us, you could say 70 is not an outlier. Okay, so then that means hence reliable prediction. Okay, I prefer number 1. And because it's the most general thing. So if you're extrapolating, you can say, well, extrapolation is not always reliable. And if we're interpolating, it is fairly reliable. Okay, so I would stick with that, to be honest. Okay, then let us move on. So that was the first question. Not too bad, bit of stats. Now let's look at question 2. The number of emails received by an individual daily over a 50-day period. Okay, so this is important. Is illustrated in the table below. Okay, so 50-day period. Okay, so here the number, we have the number of emails over here in this column. So it's between 0 and 10 and the frequency is 13. Okay, so let's be careful here. So it's not saying that they got 13 emails, right? What it's saying is on 13 days they got between 0 and 10 emails. Okay, they got between 0 and 10 emails. That's what this is saying. Okay, so we need to understand it, because if you add all these frequencies, you will get 50. Okay, because we did this over 50 days. Okay, So for example, for 21 days, they got between 10 and 20 emails. So for example, if they got 17 emails in a day, then they would add 1 to this frequency over there. Okay, so just make sure that you understand the table and what's happening with the data before you go into the questions. Okay, now they say determine the estimated mean of the data. Okay, so estimated mean is given by this symbol. Okay, and what we do is we use the midpoint. Okay, we're going to use the midpoint of all these intervals. Okay, so the midpoint between 0 and 10, quite easy, that's 5, and 5 times 13. Okay, so you take the midpoint times the frequency. Okay, then what you do is you take the next midpoint, which is 15, times the frequency. Okay, nice and easy. Plus next midpoint 25 times the frequency, plus next midpoint times the frequency. Okay, and we divide by the total. Okay, the total number of days, 50. Okay, so if we do this in the calculator, I will show you what we get. We're going to get 5 times 13 plus 15 times 21 plus 25 times 12 plus 35 times 4. We take that, divide by 50. Okay, and we get 16,4. Okay, 16,4. Okay, we don't need units over there. Cool, just 16,4. Okay, now they say represent the data on the cumulative frequency curve, ogive, cumulative frequency. Okay, I only stuttered a bit there. All right, so let's have a look. So very important with the ogive, it came up in one of the past papers. I remember a video I did recently, I forget which one, but yeah, the one you had to do a frequency polygon, I believe it was. Okay, so when you do an ogive, very important. So my main point here is when you do an ogive, you plot the endpoints. Okay, so we're going to be plotting 10, 20, 30, and 40. Okay, so remember that from theory. Okay, we don't plot the midpoints. Okay, so for example here, we're going to be plotting number of emails is 10. So we're going to be plotting somewhere on this line, essentially. Okay, more of a straight line now. And the frequency is 13. Okay, so here's 10. And each little block represents what? 12, 14, 16, 18. So each little block represents 2. So here would be 12, and halfway in between would be 13. Okay, so here's the point 10, 13. Okay. Now what we're going to plot is, we're going to plot 10, 21, which is here. If you don't have a problem with this, and you weren't starting to write angrily in the comments, you need to think. Okay, we need to have a think, because it's the cumulative frequency curve. So what we do is we can't just plot 10 and 13 and 20 and 21. What we have to do is we have to plot the sum of these, okay, which is 34. So we're going to plot 20 and 34, not 20 and 21. Okay, so we plot 20 and 34 over here, because it's the cumulative frequency. Okay, now what are we going to plot? We're not going to plot 30 and 12. We're going to plot 30 and 34 plus 12. So now what are we at? 46, right? So we're going to plot 30 and 46. 30 and 46, 2, 4, 6 over here. Okay, now we're going to plot 40 and 50. 40 and 50. Okay, we have to end at 50 because there were 50 days. Okay, 40 and 50. Okay, so this is our ogive. So we always start at the origin for our ogives. Okay, so it's going to look more or less something like this. I'll try again. There we go. That's a bit better. Okay, so our ogive will look like this. Okay, so let's just have a look here. Cumulative frequency, coordinate endpoint. Okay, so you have to label these points. Okay, so this would be 10 and 13. This would be 20 and 34. This is 30 and 46. And then this would be 40 and 50. Okay, so you do need to label those. So you get a mark for your shape. You get a mark. You get a mark for your shape, and then you get a mark for all of these all of these coordinates, I believe. So yeah, make sure you just label the coordinates. Okay, so that's our ogive. Okay, that is our O drive. We might use it. For question C, they say we have to use our answer in A, and by determining the median as well, so we're going to have to find the median. Would you describe the data as positively or negatively skewed? And we need to explain. Okay, so what we need to be checking is, well, our answer from A was a mean, right? So a mean, and we got 16,4. Okay, so basically what we need to be doing is we need to be checking the mean, and we need to be checking the median, right? Q2, the median. Okay, so if the mean is to the right of the median, okay, so if the mean is bigger than the median, that means we'll have positively skewed, okay, and vice versa. So if the median is bigger than the mean, then it'll be negatively skewed. Okay, so let us have a look. So there's two options you can do here, right? So first, we already have this, right? We already have the mean, so we need to find the median, okay? And they do tell us we need to determine the median, okay? So let's have a look. So we have over here a 50-day period, okay? So to define the position of the median, right? The position, what we're gonna do is we're gonna take 50, add 1 to it, and divide by 2. Okay, so if you do that, you're going to get 25,5. Okay, so the position of the median is between the 25th position and the 26th position. So it'll be in the middle between that. It'll be the average of the 25th and 26th entry, right? So what you'll see there is it will lie in this interval, okay? Because if you take 13 plus 21, you get 34, okay? So up until here is 34. So it has to lie in this interval, okay? Because here would be 13, and then here would be, it would lie somewhere in here, okay? The 25th and 26th position. It will lie somewhere in this interval. So we take the midpoint, okay? So from that, okay, we get that Q2 is equal to 15. All right. So what we have there then is we know that the median is 15, okay? And what we have then is our mean rather is bigger than our median, right? We can say therefore. So we can say that, well, therefore data is positively skewed, okay? Positively skewed. Okay. So that is one option, okay? They do allow you to read off of the ogive. They say or read off the ogive, okay? So currently the memo only has this where we read off from here, okay? The memo only really gives an answer for this, okay? One issue that comes up, I want to just talk about it quickly, is if you read off the ogive, so for here, the 25th position would be 2, 4, 6. So it'll be somewhere here, right? There's 25, maybe a bit higher. Okay, maybe something like this. Okay, so if I read off my median from here, I will find my median is over here. Okay, there's 16, there's 70, so it'll be 16 comma something, right? It looks like it's going to be like 16,7, 16,8. So if I read off of my ogive, I find the opposite of this. I find that Q2 is equal to 16,7, right? And remember our mean was 16,4. So I'm actually going to find negatively skewed, okay? But that isn't what is shown on the memo, okay? But if you've ever done an IEB past paper, I'm sure a lot of people skip over it. But in the front, in bold, they say that, you know, essentially what they're saying is that if you don't come to the standardization meeting, you're going to have different interpretations or application of the marking guidelines. So essentially, I think what that means is the memo is not exactly final. There are other options that they might have marked correctly. And I think something like this, as long as you read off your ogive correctly, I think they will mark this right. I'm not an IEB marker, but I think they will. I just want to talk. I just wanted to talk about this because it has come up before, and yeah, it's just something to keep an eye out for. For question 3, we need to simplify this trig thing over here without using a calculator. So what we need to do is we need to realize that we're going to have to use one of these, okay? Because if you look at this, it's in the form of where you have sine times by cos minus cos times by sine. So what actually happens there is it matches. We need to see which one it matches. So we have sine times y cos, and then cos times y sine. So it matches this one, right? It matches that one. So you'll see there's no sort of 90-degree reductions and stuff you can do. So you needed to see that it matched this one over here. Okay, so essentially what that means is that this thing then is equal to sine of 85 degrees minus 25. Okay, because it matched this one over here. Okay, and then that's just sine of 60 degrees. And I'll just say without using a calculator, but if you really don't have to memorize the special angles. Okay, you really don't. So sine of 60 is just, what is that, √3/2. Okay, so from this point they won't be able to tell if you know your special angles off by heart or not, because yeah, so you can use your calculator at that point. Okay, so we get that. Cool. All right, next question, let's say simplify this. Okay, so here we have 90-degree reductions and stuff, so it's going to be a bit different to the previous question. Okay, but anyway, simplify this. So negative tan becomes, sorry, tan of a negative theta becomes negative tan theta. Okay, because a negative theta means we are in this quadrant, and only cos is positive here. So that means tan is negative. Okay, then if we do sine 90 plus theta, that means we're in the second quadrant. So let me leave this up here. All students take calculus, the cos diagram. Okay, so 90 plus theta means we're in here. So the sine is positive, but sine changes to cos. So it becomes cos theta. Okay, let me put this back in blue. Okay, so that becomes cos theta. All right, nice and easy so far. Plus sine 2 theta. So from our formula sheet, that just becomes 2 sine theta times by cos theta. I know I have a really good idea I need to change that, because here I'm dealing with 2 theta and everything else is theta, right? Okay, and here at the bottom, 360 plus theta just means I'm in the first quadrant and cos is positive there. Okay, so I just get this thing over here. So let's simplify now. Those are going to cancel, that's going to cancel. Okay, so, but also I can rewrite tan as negative sine theta over cos theta, right, times by cos theta plus sine theta. Okay, and then what's going to happen is these are going to cancel. All right, and then what I have there is just negative sine theta plus sine theta, so that's just 0. Okay, final answer of 0. All right, question C, we're given that cos x is equal to p, and we're between, our angle x is between 0 and 180 degrees. Express the following in terms of p. Okay, so here we just know it's p over 1. Okay, so cos we know is x over r. Okay, so cos of theta is equal to x over r. Okay, and what we know is we're positive. Okay, so we have to be in the first quadrant, right? Because cos, our angle's between 0 and 180, and we're dealing with cos, and it's positive. So what we're going to do is we're going to draw this thing over here. Here's our, so this actually isn't theta, it's x, because we're dealing with the angle x. So essentially our r is 1, so we know that's 1, and we know our x value is p. Okay, so to find this, we can just use Pythag, and you'll find that it's 1 minus p squared and the square root of that. Okay, so that's what our y is. Okay, so sine x is just going to be, so if we do sine of theta, or sine x, it doesn't matter what angle we're using, that's our y over r. Okay, and our y is this thing over here. Okay, and our r is 1, so this is just 1 minus p squared. Okay, then for this next question, cos of 2x, the thing is here we're dealing with angle x, so we need to change this cos 2x to something that we need to change it to something that deals with angle x, right? So what we can do is we can just rewrite this as 2 cos squared of x minus 1, right? Using, let me show you what we're using. So we need to use one of these, right? Because here we have 2x, and we want to change that to just angle x, right? Because we know what cos x is, for example. Okay, but we don't know what cos 2x is. Okay, so if we deal with this, this is just 2 times pi, and cos x is p, so this is 2p squared minus 1, so that's just 2p squared minus 1. Okay, that would be our answer over there. Okay, cool. Now for D, they say determine the general solution of the following. Okay, so what we have here is we have sine on this side and cos on this side. Okay, and then the same angles in here. So what we can do is just divide both sides by cos to then get tan, right? So what we're going to do is we're going to get 2 tan of x minus 30 degrees is equal to 1. Okay, because we're dividing both sides by cos x minus 30 degrees. Okay, this side as well divided by that. Okay, let me write it here, cos x minus 30 degrees. Okay, so we get this, so we get tan of x minus 30 degrees is equal to 1 over 2. Okay, so what I do at this one, I use, if you use that textbook a lot of schools use, it's, I think, Mark Phillips, whatever, yeah, so I use what he calls a graphical method. So yeah, your school might teach it differently, but you can do it your way. You should end up at the same answer. It will look different, but it will be the same. But anyways, if I continue with that, I just get this. So our angle is equal to tan minus 1 of a half plus k 180. K is element of integers, k's. Okay, so what we do now is I can do tan minus 1 of a half. Okay, that gives me 26,56, and then this 30 is going to go across to the other side, so I can just add this to that. Okay, and I'm going to get 56,6. okay, so I'm going to get x is equal to 56,6 degrees plus k 180. K is an element of integers. Okay, really, those are really messy. Okay, but yes, that is what we have over there. Okay, moving along, question 4. We're given two functions. Here's our first function, here's our second function, and we're plotting for 0 to 360. Okay, as you can see over here. So we need to sketch both of the graphs on the same set of axes below. We need to label intercepts with the axes, turning point, and endpoints. Okay, so you could kind of memorize that this is just normal sine graph with amplitude of 2, and this is just a cos graph shifted 30 degrees to the left. Or, right, we can use the calculator, right? We can just use table mode. Okay, so we go 7 for table mode. Here we can put 2 sine x. All right, and here we're going to be doing cos of x plus 30 over there, and we're going to start at 0, we're going to end at 360, and we're going to step, well, you can see here this thing, let's not step in 90s because you can see there's little sub marks over here, so this would be 30, 60, 90, 120, etc. right? So let's step in 30s. Okay, so remember this fx is the sine 2x, so let's plot that one first. Okay, so we got 0 and 0. Okay, the calculator is going to spring away, so but anyways, we have 0 and 0. Okay, we're going to have 30 and 1. All right, and then we're going to have 90 and 2, so that's an important one. So technically we don't even need this one over here. Okay, we don't need that one because remember we just need to plot the turning points and intercept with axes and endpoints. All right, the next important point is 180 and 0, so over here. Then the next important point would be 270 and -2, right? Because that's where we turn. So 270 -2, and then we're going to end up at 360 and 0. Okay, as our endpoint. Okay, so how this function would look would be like this, something like this. Okay, remember it's just a normal sine graph with just double amplitude. Okay, so let's not label the points just yet, okay, because we don't know how our other function g of x is going to look. Okay, we don't want to be going through our labels. Okay, but anyways, let's go back to the calculator, and now we're just going to be looking at our column for g of x. Okay, so we start at this point. We are going to have to label this, okay, because we intercept with the axis at this point. Okay, my calculator just crashed. Okay, we're back. So it's going to be 0 and 0,9, right? So it'll be about here, okay, as our first point. Then our next intercept with the axis at 60 and 0. So here's 60 and 0. Then let's see what else happens. So we got 150 and -1. Okay, and you can see we turn here. Okay, so 150 is over here and -1. So we're going to turn here. And let's see when else do we intercept with the axis. So you can see here at 240, 0. So 240 and 0 would be here. Then do we turn again? Yes, we do. We turn at 330, which is up here. Okay, sorry, that is not 330. 330 is over here. We turn over there, and then our endpoint is 360 and 0,9 again over here. Okay, so this is how g of x would look like this. Okay, so now that we know how our graphs are going to look, we can label some points. Okay, so this is 0, 0. This is 90 degrees 2. I should probably put degree up here. Okay, then here's the intercept, so we need to label this 180 degrees 0. This is a turning point, 270 degrees -2. And over here is an endpoint / intercept, so 360, 0. Then now let's label the important things for g of x. So this point over here is 0, 0,9. Okay, this one is 60 degrees and 0. Let me put the degrees up there. This is a turning point, so we need to label it. This was 150, so 150 degrees -1. This is intercept, we need to label it. That would be 240 degrees 0. And this is a turning point, so we need to label it. It is 330 degrees 1. And then this is 360 degrees and 0,9. Okay, so yeah, just make sure you label all of those. Okay, this one's a bit messy over there. Okay, so should be an easy 6 marks. You can see how we can just use a calculator over there. Okay, now they say show how the graph of g can be written as this. Okay, and you might look at this and be saying, what, how does that get there, right? But let's look at g. Okay, g is given by cos of x plus 30. Okay, so when we have two angles in here, right, what we can do is we can apply one of these, okay, because we have cos x plus 30. So do you see how it's the same form as this, where this is our x and that's our 30? Okay, so whenever you see an alpha, we're going to put an x, and whenever you see a beta, we're going to put 30 and 30. Okay, because if you think here, this √3 in this half, well, that's √3/2. And we might think, where do you get that? Oh, that's one of our special angles. Okay, so that kind of pointed you a bit in this direction. Okay, I know it's not completely obvious, but yeah, because we have two angles in here, we can split it like this. Okay, so what we can do is we can say, well, g of x can just be written as cos x times cos 30 degrees minus sin x times sine 30 degrees. Right, okay. So cos 30 degrees, remember, you can just use a calculator. So cos 30, what is that? √3/2. Okay. So basically here we have √3/2 cos x. Okay, minus, now what is sine 30? So sine 30 should just be what? 1/2, right? Sine 30, 1/2. Cool. So minus 1 over 2 sine x. Okay, so you can see here, well, how did they go from this step to this one? Well, they just took out a half. Common factor of a half, right? So then what's left behind is root 3 cos x minus sine x. Okay, and there you go. You've shown it. You've shown how gx can be rewritten as this. Cool. Now for C, they say clearly indicate on your graph the values of x for which this thing. And then they give you this. And you might be thinking, what? Where is this? Okay, but let's have a think. This thing, all right? So remember also in maths, you often use what you've, to solve C, you're gonna have to look at what you did in B and A, right? So let's look at what we did in B. Okay, because we're lost here. We're thinking, what? Where did they get this, right? What sorcery happened here, right? But let's have a look. Where does this thing come about? Okay, where does that come about? And you'll see that that thing comes about here. Okay, so it comes from here. Okay, it's just without the half, right? But if you think, how do you get rid of this half in front? Well, you can just times this side by 2. Okay, if you times this side by 2. Okay, but remember, if you times the right by 2, you have to times the left by 2. And if you think, okay, where did this 4 sine x come from? Okay, because I have 2 sine x. Okay, but if you have a look, right, what do they often ask when they say indicate on your graph? You often have to do something like this when the two functions are equal to each other, right? Well, I know my f of x is 2 sine x. Okay, here's my f of x, 2 sine x. And I know my g of x is a half root 3 cos x minus sine x, right? So can you see what they did here? To get rid of this half, they just times both sides by 2. So here we have sine x is equal to root 3 cos x, right? Cos x minus sine x. And where did this come from? This came from f of x is equal to g of x. So basically they're just asking, show where the two functions are equal to each other. Okay, so it didn't make sense, and we made it make sense. Okay, this comes up all the time in maths, guys. Okay, so if you're stuck, use what you did in B, and then also use what they asked before. Okay, what have they normally asked before in past paper questions like this? They normally ask where the two functions are equal to each other. Okay, so what we need to do is we just need to indicate where the two functions are equal to each other. Okay, so just also be careful. They say clearly indicate the values of x. Okay, so you're going to have to show on the x-axis, okay, that this is one of the points, okay, that they're equal to each other, and here's the other point over here, B. Okay, you have to say where you would read off, okay, the values of x, right? You don't actually have to say, right? You just need to indicate where this happens. Okay, so you don't actually have to solve for the number. What you do is you just need to show that we need to read off these x values. Question 5, they say AB is the diameter of a circle with center O. Okay, so very important we have a diameter. So let's see if anything is 90. Well, we know that all of this is going to be 90. And we have center O, so this is a radius, that's a radius, that's a radius, and those are all our radii over there. Okay, they say that D and E are points on the circle, so that DO is parallel to EB. Okay, that's another important bit of information. They say C is a point on the circle as shown, and then they say that O1 is equal to 40. Okay, so very important, they haven't shown that this is 40, so let's add that in. Okay, O1 is 40. Cool. Now they say determine angle A1, which is over here. Okay, so I'll go over here because it's a bit bigger. So they're asking for this angle over here, A1. So, but if we work in triangle DAO, right? If we work in this triangle, you'll see that, well, we know that this is 40, and we know that A1 is equal to this thing over here. Okay, so what we can do is we can say, well, we can say that OA is equal to OD, right? And that's because they're both radii. All right. So we can say that, well, therefore A1 is equal to, angle A1 is equal to angle D. I'm just going to call it ODA, like this, ODA. And the reason there is angles opposite equal sides, or you could just write isosceles triangle over there. So what we're going to have then is 2A1 plus 40 is equal to 180 degrees, and that's because of angles in a triangle. And then we can just solve for A1 using algebra, and we'll get that it's 140 divided by 2, which is 70 degrees. Okay, we can say therefore A1 is equal to 70 degrees. Okay, cool. Hopefully not too bad. 2 marks in the bag. All right, now they say determine this angle E over here. Okay, so again, let's just go back over here. Now they want E, this angle over here. All right, so let's have a look at what we can do. All right, so if I get rid of some of this that we were just doing, I see that we have a cyclic quad, right? We have the cyclic quad over here. Okay, remember cyclic quad, the definition is a quadrilateral where all 4 vertices lie on the circumference of a circle. And you can see we have 4 vertices, they all lie on the circumference. Okay, they say C and D are points on the circle, all right, and AB is the diameter, so they have to be lying on the circumference. All right, so they ask for angle E, but I know A1. Okay, so I know that in a cyclic quad, opposite angles are supplementary. Okay, so I can find E, right, by just saying, well, E is going to be equal to 110 degrees. And that's because of angles. So this is opposite angles of a cyclic quad. Opposite angles of cyclic quad. Opposite angles of cyclic quad. Okay, easy as that. There are other alternatives that you could have done to find E, but I'm going to stick with this one. This one was the easiest, okay, for 2 marks. You can have a look at the memo if you would like to look at some of the other interpretations, but this one was the easiest. Okay. Now they say determine angle C1. All right, let's go back over here. Let's get rid of this. And we have to determine angle C1. All right, so angle C1 is over here, but we know that the whole thing is 90 over here, C1 and C2. So maybe there's a way we can find C2, and I do see a way to find C2, and it's because we have another cyclic quad, right? We have this. Here's another cyclic quad. So I know E, so I can find C2, right? Because again, opposite angles in a cyclic quad. So what I can say is C2 is equal to 70 degrees, okay? And that's because of angles of cyclic quad. Cyclic quad. All right. And then I have that C1 plus C2 is equal to 90 degrees, and that's because of angles in a semicircle. All right, so therefore C1 is equal to 20 degrees. Okay. Another interpretation you could have done for this is that here we have an angle at center, and this is angle at circumference. All right, so you could have done that C1 is equal to 20 degrees because angle at center is equal to 2 times angle at circumference. Okay, you could have done that as well. Okay, because we were working with cyclic quads and because we just did E in the previous question, right? We just determined E. I'm going to use E to then find C2, which will then find me C1. Okay, but again, you could have seen that angle at center is equal to 2 times angle at circumference over there. Okay, now they say determine B1 for 1 mark. All right, so let's have a look what they're asking for here. Okay, they are asking for B1, this angle over here. So here we have parallel line, there we have a parallel line, So here we have corresponding angles. Okay, so it's quite easy. So B1 is just equal to O1, which is 40 degrees. And that's because of corresponding angles. And that's because DO is parallel to EB. Okay, so not too bad over there for B1. Okay, now for the final question here, they say if AE is constructed and intersects DO at F, determine the length of AE if the diameter of the circle is 9 units. Okay, so a lot going on over there. So let's erase all of this and let's look at this. So they say we need to construct AE and we're intersecting DO at F. Okay, so let's have a look. So if we construct AE, it's going to be something like this. Let me fix this. Something like this, more or less. And we're intersecting DO at F. So this thing would be called F. And they also say we have to determine the length of AE if the diameter of the circle is 9 units. Okay, so here is the diameter, 9 units. We know that AB is 9 units, the diameter. Okay, and basically, well, what the question is asking for is what's the length of AE? All right, so what we know is what we've just constructed here at angle E, this part of E over here, AEB, this angle is 90 degrees, right? Because of angles in a semicircle. So we might be thinking Pythag, okay? We could be thinking Pythag to find AE, but that means we would have to know EB, which we don't really have any information about that, right? But we have a 90-degree triangle, right? So we can think of trig ratios. And then also we know what B1, because we just solved B1, right? 40 degrees. So do you see how in this question we've been using what we've just did in the previous question to help us in that question? Okay, so B1 is 40 degrees. So here it's just a simple trig ratio, right? So yeah, so what we have here is we're trying to find the opposite and we have the hypotenuse. So what is that? We're going to use sine 40. Okay, but we do need to give some reasons. So we're going to be saying that angle BEA is equal to 90 degrees, and that's because of angles in a semicircle. Okay, and so what we can then say is it's better if we say in triangle, we can say in triangle EAB, so working this triangle, so let me do a better triangle over there. So when we're dealing with this triangle, we have sine of 40 degrees is equal to AE over AB, which is 9. Okay, because here again we're doing trig over here. This is my opposite, this is my hypotenuse in this triangle. Okay, so we can just solve easily over there for AE. We will find that AE is just 9 times sine 40. So I will show that on the calculator. Here we go. So we have 9 times sine 40, and that gives me 5,8. Okay, they wanted to one decimal place. So AE is equal to 5,8 units. Okay, not too bad. I hope question 5 was not too bad for you guys. Moving over to question 6. They say AC is the diameter of a circle with center O. So let's see, do we have any radii? We do. This is a radius, that's a radius. We could construct a radius. That's maybe something we need to keep an eye out for. But because we're kind of moving into the section where constructions might be, we might have to do constructions, but normally we don't really do constructions when the mark allocation's kind of smallish like this. But anyways, it is possible. Let's have a look. So what else do we have? They say B is a point on the circle. AB is produced to D such that DC is a tangent. Okay, so important, DC is a tangent. This is a radius, so this is 90 degrees. Okay, that might be useful. AB is 5 units, here's AB. BD is 4 units, that's 4, so we know this entire length is 9. Could be useful, and again, we have this angle is 90, so we might be able to do Pythag. We're just looking through at our options. They say C2 here is X, so this angle's X. And yeah, that's everything. They say determine angle A in terms of X. Okay, angle A in terms of X. Okay, but remember DC is a tangent. Okay, so A is equal to X. Well, we can say that A is equal to C2, which is equal to X, and that's because simply just from tan chord. Okay, that's just from tan chords here. Tan chord. All right, nice and easy again for 2 marks. So if you know your theorems well, these 2 mark questions have been quite easy so far. Well, I hope they've been easy if you know your theorems. All right, now they say we need to prove that CBD is parallel, sorry, not parallel, this means similar. Okay, so if it's 3 lines, it's similar. If it's 2, it's parallel. We need to show that CBD is similar to ACD. Okay, so let's have a look. So first triangle is CBD. So here's CBD. Okay, here's angle CBD. One thing I didn't mention is this is 90 degrees because AC is the diameter. Okay, that's going to come in handy now when we do that problem. But anyways, here's our one triangle CBD, and the other one was ACD. All right, so ACD is where? Here's ACD. It's a big triangle over here. ACD. Okay, so immediately you can see that D is common, a common angle between them. So that's going to be important. You can say that, well, angle D is common. All right, well, we should first start by saying in triangle CBD and triangle ACD. So we start off with that. All right, D is common. Okay, now we just need one more angle that are equal to then finish the similarity. So we know that angle ACD is 90, okay, and that's because of radius perpendicular. Well, let's just say that, right? So we can say that angle ACD is equal to 90 degrees, and that's because of radius is perpendicular to a tangent, and we know that B2. Okay, well, let's first say that B1 is equal to 90 degrees, and that's because of angles in a semicircle. Okay, semicircle. So that means therefore B2 is equal to 90 degrees, and that's because of adjacent angles on a straight line. Adjacent angles on a straight line. So you can just write straight line like this. So yeah, let me just clarify that. So this is 90 because this is a diameter. So then this must be 90. Okay. So from that we have that therefore ACD, I put the cap in the wrong spot, ACD is equal to angle B2. So we have that, and then what we have is therefore, so we have D is common, this angle is equal to that, so what is left is, oh, and we even knew that C2 is equal to A. We did that here, okay. So, but what we also know is we can say it over here. We don't have to say this. We could say interior angles of a triangle, but we do know that angle A is equal to C2, all right, and that's been proven before, okay. So I'm gonna keep continuing here on the right. All right, so what we have then is therefore triangle CBD is similar to triangle ACD, and the reason there, remember, is angle, angle, angle. Okay, that is our reason over there. Okay, so we've just proven this, so in C we need to keep that in mind. Okay, we need to keep in mind that the triangles are similar. Okay, so we know that AB over here, let's work with the big triangle. So we know AB is 5, BD is 4, and AD is 9. Let's not forget that. Now they say determine the length of tangent CD, this thing over here. Okay, so we have AB, we have BD, and we also have AD. Okay, So let's look at a ratio in a similar triangle that deals with CD and then also has AB, BD, or AD. Okay, so if we look over here, where is, again, we're looking for CD. Okay, so CD is here. Okay, so CD over, that's going to correspond over here to BD. Let me use a different color. So CD corresponds to BD. Okay, so CD over BD. Okay, and we have BD. We know this whole thing was 9. Okay, now let's think of another thing we know. We know BD. Okay, we've already used BD. No, wait. Okay, yeah, sorry. I messed up here. So here's BD, there's AD. Okay, but we do know BD. BD is given as 4. Okay, so CD is what we're trying to find. We don't know this, but we do know this. Okay, we know it's 4. So let's think of something else we do know. Okay, so we could do we know AC? We don't know the length of AC. So let's try something we do know. We do know the length of AD. Okay, so then what we're going to do is we're going to say AD over CD. Okay, because again, we know AD and we're trying to find CD. Okay, but that's fine because this is our only unknown, CD. Okay, so this shouldn't be here. Right, so I'm going to move this across for us to where we need it. We need it over here. Okay, so we know this, and what is the reason for this, right? And that's because triangle CBD is, you could just say, yeah, so we need to be saying that the triangles are similar. Okay, what was our other triangle? ACD. Triangle ACD. Okay, so the sides are in proportion. Okay, so now we just need to do some algebra. We can cross multiply, so we get CD squared is equal to, well, AD is 9, so that's going to be 9 times, and then BD over here was 4. Okay, times 4, so 9 times 4 is 36, so CD squared is equal to 36 rather, so therefore CD is equal to 6 units. Yeah, CD is 6 units. Cool. That wasn't too bad, hopefully. Okay, now question 7. They say in the diagram that AC is the diameter. They love diameters in this paper. Okay, we'll be dealing with diameters. Okay, with circle center O. So we have a diameter, so we know that this is 90. And we also know that this is 90 because of that diameter. And then here's the center, so this is equal to this. And those are the only radii we have over there. They give B1, this angle over here, is 67.5 degrees. Okay, that angle over there. So it's a bit messy. Let me use a different color rather. Okay, so when they give us B1 like this, that's a bit too far. Because they give us B1, we can determine B2 quite easily, right? So B2 will just be 90 minus this angle here. And then C1 is 45 degrees. Okay, let us have a look. What could they possibly ask us? They say, is ABC an isosceles triangle? Explain. So here we have ABC, triangle ABC. And they ask, is it an isosceles triangle? So we need to prove that A1 is going to be equal to C1. Okay, and that is true. Okay, and the reason is because this whole angle is 90. Okay, so let's have a look at that. So what we can say is angle B1 plus B2 is equal to 90 degrees, and that's because of angles in a triangle, not because of angles in triangles, sorry, angles in a semicircle. Okay, so what we have also is C1, right, is equal to 45 degrees, and that was given. And then, so what we can say is, therefore, A1 is equal to 45 degrees, and that's because of angles in a triangle, right? Because in this triangle, if this is 90 over here, and this is 45, this has to be 45, okay? Because remember, the sum of angles in a triangle is 180, okay? And then we can say A1 is equal to C1, okay? and we can then say therefore, so I ran out of space here, but therefore ABC, triangle ABC is an isosceles triangle. Okay, is an isosceles triangle. Okay, so you can just say that over there. You could also say that the sides opposite equal angles. Okay, cool. So we have that, and now for the final question for this problem, well, the final question for this question, right, this final sub question B, is we need to prove that A1 is double A2. Okay, so this kind of looks like angle at centers 2 times angle at circumference. It could possibly be like that, but let us have a look. So here's A1 and here's A2. So we need to be looking at these two. Okay, so I'll keep the diagram as is. I know it's a bit bloated, but here's A2. So we need to be working between these two angles. Okay, so this is 45. So this needs to be half of 45, which is 22,5. Okay, so let's see what else A2 is equal to. Well, A2 is equal to B2. Okay, because if you look at a bow tie, so I'm going to erase a lot here. Okay, but if you look at the bow tie method or the spider eyes, you can see that the Spider-Man eyes rather, you can see that we have this. Okay, so this angle is equal to that angle. Okay, do you see that Spider-Man eyes going on over there? Okay, but we can find B2. Okay, because B1 plus B2 is 90, and we have B1. Okay, so we have that B1 is equal to, and if we do 90 minus 67,5, what do we get? 90 minus 67.5. Well, we're hoping we're going to get 22,5, and that is indeed 22,5. All right, but we knew that anyways. Well, we were looking for that, right? So B1 is equal to 22,5 degrees. Okay, and we've already used angles in a semicircle, so this is fine, just by giving this as a statement. So B1 is equal to 22,5, and then we can say, well, therefore A2 is 22,5 degrees, and that's because of angles in same segment. Okay, and then, well, therefore A1 is equal to 2 times A2. Okay, so we already know that A1 is 45 degrees. Okay, apparently you do get a mark for saying that A1 is equal to 45 degrees. So somewhere over here, A1 is equal to 45 degrees. Okay, and that was already shown, proven. Okay, apparently you get a mark for that. So yeah, I guess just be careful with that one. All right, and that is half of the paper done. Okay, so we haven't done any constructions yet, so we need to keep an eye out now for this next section. We might have to be doing a construction in a problem. Okay, everyone's favorite question, question 8, we have to do a proof. Okay, so again, what I've recommended time and time again, I don't recommend you memorize all the steps. Just memorize what you need to do. What is the main method that you're going to do the proof? Okay, so we need to prove the theorem that states a line drawn from the center of the circle perpendicular to the chord bisects the chord. Okay, so they tell us we need to prove this. Okay, we need to prove that this is equal to this. Okay, and what we should remember is, well, we just need to do congruent triangles. Okay, so we're going to have to draw, our construction is a radius, well, radii OA and OB. Okay, we just need to construct those radii. Okay, so we've constructed those radii, and then obviously we need to do congruent triangles. Okay, so let's move over here. We have just constructed that. Okay, so we're doing congruent triangles, so we're going to say in triangle OAC, and so it's very important that the triangles align. Okay, so we went OAC, so here we're going to have to go OBC. Okay, OBC. All right, and I have no idea why I'm putting these caps all over, because they're triangles. Okay, in triangle OAC and triangle OBC. Okay, OBC. So in these triangles, right, what do we have? Okay, well, we have OC is common. Okay, it's a common side. All right, OC is a common side, and then we have that OCA is equal to OCB, and that was essentially given, right? Because if this is 90, that's going to be 90. And also what we have is this side is equal to that side because of radii. Okay, so OB is, well, let me say OA is equal to OB. Okay, and that's radii. Okay, so let's see what do we have? Right, so we have this side, we have this side, and we have this angle. So you might be saying, whoa, right? If we're going to do side, angle, side, we need this angle. Okay, but remember, this is the special one where we have, it's RHS, right? RHS, where we have a right angle, we need the hypotenuse and one more side. Okay, we have a right angle, here's the hypotenuse, and we have one more side. Okay, so we're actually sorted, okay, over here. So we can say that therefore triangle OAC is equal to triangle OBC, and the reason is RHS, as I was saying. And we're not done yet, because remember, we're required to prove this. Okay, AC is equal to CB. Okay, and then therefore AC is equal to CB. Okay, so I mean, technically we have that AC is equal to BC. Okay, AC is equal to BC, but remember, it doesn't matter what order we write it. So CB is equal to BC, because it doesn't matter if we measure this length that way, right? If we measure it that way or this way. Okay, so they're the same thing. So I would recommend obviously write this, because what did they ask? They said required to prove this. So don't write BC. Okay, write CB. Okay, so that should be super easy. How many marks with this? How many marks? So I left out how many marks. This was 4. Let me just quickly check on the question paper. This question was for, where is this? Question 8. So this was for 5 marks, this proof. Okay, this proof was for 5 marks. So I left that out, but it's for 5 marks. Okay, should be pretty easy 5 marks. Okay. Now for question B, they say in the diagram O is the center of the circle. Chord AB is 8 units, so this thing is 8 units. They say the perpendicular distance from the furthest point C on the circle to chord AB is 8 units. Okay, so do you see how they haven't given us much filled in things here, right? There's not many lines. Okay, but let's check the question. They say determine the radius of the circle with center O. All right, so this kind of looks like a very obvious construction thing, right? Because they say determine the radius, and they haven't even constructed any radii. Okay, so let's do that, right? Let's construct some radii. So OC is a radius, OB is a radius, and OA is a radius. Okay, and then also we know that this distance, right? We know that from C to this point is 8 units as well. Okay, so AB is 8 units, and then also we know that yeah, so AB is 8 units, but we also know from C to this point is 8 units. Okay, so we needed to do some constructions over there. Okay, so we have this, I'll do in a different color, that we also have that this distance is 8. Okay, so I'll call this D. Okay, so we have that CD is also equal to 8 units. Okay, so they are asking for the radius. Okay, so let's make some radii. Okay, let's call the radii X. Okay, so this is X, that is X, and also this is X. Okay, we can also show that this is 90 degrees because the perpendicular distance, they kind of do give us this is 90. Okay, because we know that this is perpendicular to that point over there. Okay, so we say that this perpendicular distance is just going to meet here at D. So that's 9. This is 90. So then we know that these two lines are equal. So this is 4 and this is 4. Okay, so we can work in any of these triangles, okay, to find the radius. So for example, if we work in this triangle, we have this, so we now just need to determine what the distance OD is. Okay, so let me make this diagram a bit more clear for us. Okay, we don't technically even need this stuff up there. Okay, so we're obviously going to be writing all this stuff down, but we're just currently looking over here. Okay, so we know that this distance is 4, we know that this is 90, so we're looking for Pythag. Okay, the only issue now is we need this distance OD. Okay, we need this distance OD, but we know CD is 8, right? So we have CD is 8 units, and we know that OC is equal to X, right? So then this distance has to be 8 minus X, right? Because let's say this was 5, OC over here was 5, this would have to be 3, right? Which is 8 minus 5. Okay, so now we have everything we need, right, to do Pythag in this triangle. Okay, because there's only one unknown, X. Okay, so let us write all of those things. Okay, so what I'm going to do is I'm just going to quickly fill in essentially what we're doing. Okay, so we're just doing this. This is 4, this is 8 minus X, and this is X. Okay, and this is 90. All right, but let's write all these things. Okay, so, and this was D, we call this D. Okay, so we have that BD is equal to DA, and the reason, and they're both equal to 4 units, and the reason there is a line from center perpendicular. Line from center perpendicular. Okay, and we know it was perpendicular because this was a perpendicular distance, so we just extended, we just knew that that was 90, right? So we're just letting that line meet over there. Okay, and CD goes through the center. Okay, so that has to be 90 over there. Cool, so we have that, and then if we look in this triangle, OAD, all right, so if we look in this triangle, we can say let OA is equal to X. Okay, so if we look in this triangle OAD, so technically it would be ODA. All right, so in triangle ODA, what we have is we have OA is equal to X. We have that AD is equal to 4. We have that ODA is equal to 90 degrees. Okay, and we have that OD is equal to 8 minus X. Okay, so what we can do now is we can do Pythag. All right, so I'm going to be doing Pythag here. So what we have is X squared is equal to 8 minus X squared plus 4 squared. Okay, because here's our hypotenuse, so we square this side and square this side and add them together. Okay, that gives us X squared is equal to 64 minus 16X plus X squared plus 4 times 4 is 16. Okay, so essentially what happens here is these are going to cancel, and that 16x can go to the other side, so we get 16x is equal to 80. That is 80, right? Yeah, is equal to 80. So what we're going to get is 80 divided by 16 gives us, what does that give us? 80 divided by 16 gives us 5 units. Okay, so we can say that therefore radius is with the U. Radius is 5 units. Okay, the radius is 5 units. Okay, so I hope that made sense over there. Okay, so again, I just want to clarify, we knew that this was 90. Let me move over here. We knew that this angle was 90 because we knew that CD was the perpendicular distance. Okay, and it went through the center. Okay, CD goes through the center. Okay, so it's a perpendicular distance and it goes through the center, so that means that OD is perpendicular, right? Because if CD is perpendicular, then OD is perpendicular to this. Okay, AB. All right, so I hope everyone was happy with that. Okay, cool. Let's move over to question 9. So this looks like we're going to be doing line parallel to one side triangle, right? Because we have a whole bunch of triangles and we got parallel lines, so we're going to be thinking of these things, right? When you look at side ratios. Okay, not exactly those, but yeah, that's just something we need to keep an eye out, and they also give us these things. Okay, sides in proportion. So they say in the diagram ABC is drawn, triangle ABC. They say E and F are points on AC and AB respectively, such that, and then they give us this and this. Okay, so let's break that down. So they say that AE over EC is 3 over 2. Okay, so the ratio of these sides is 3 over 2. So let's just call this 3P, and we call this 2P. Okay, because we don't actually know what these sides are, right? Because it could be 30 over 20. Okay, because that simplifies to 3 over 2. So what I'm saying is this could be 30 units, and this could be 20 units. Okay, but we don't actually know what it is. It could also be 60 over 40. Which will also simplify to 3 over 2. So this one could actually be 60 and this one could be 40. So the main point is we don't know exactly how long the sides are, okay? But we do know that they're in proportion like this. So we just put this scale factor over here, okay? So yeah, I hope that makes sense. If you've practiced these problems before, you would have seen that this type of thing is helpful when we say 3P and 2P, and the side we're going to be using K's. You'll see in a second. Okay, so that's why we put the 3P. Okay, I hope that makes sense, because this distance isn't 3 and this isn't 2 necessarily. Okay, it could be, as I said, 30 and 20, for example. Anyways, we have that AF over FB is 2 over 5. So here's AF and here's FB. Okay, and it's 2 over 5. So let's call this 2K and let's call this 5K. All right. So they say that BC meets F is produced and meets FE produced in C. Okay, a lot of things going on over there, but it's basically just saying, well, BC is produced, okay, and it meets FE in D, produced in D. So basically it just says, well, we have D over there. Let that not confuse us too much. Then let's say G is a point on FB so that, and then this is important. So FD, so this line is parallel to this line. Okay, so what I want you to do is I want you to picture these triangles that we have, okay, because there's many triangles in triangles over here. Okay, so let's ignore this for now. Okay, let's look at all these triangles. All right, so it is sometimes a bit difficult to see, but what I see is if we completely ignore this, just pretend this is not here. Okay, pretend this is not here. Can you see these triangles here? Can you see this proportion over here? So FG over GB is going to be equal to DC over CB. Okay, because you see how this is parallel to this. Okay, these lines are parallel. So we have this proportion aspect over there. Can you see that? Okay. Then what else do we have? Where else do we have proportion like that? If we have a look, if we ignore this bit, and we ignore this bit, right? So let me get rid of all of this. Do you see now how we have this? We have that AF over FG is equal to AE over EC, okay? So we have AE over EC, and we have AF, right? We know that this was 2K. So we could find FG, right? Or we could possibly find FG, okay? So we're thinking of all these possible triangles that we do have. Okay, let me go back then and put in these things over here where we had AE over EC is 3P and 2P, and here we have AF is 2K over FB is 5K. Okay, so it's very important you can see those different triangles and the different ratios because you're probably going to need that. Let's get into it. For 5 marks, they say calculate giving reasons BC over CD. Okay, so BC over CD. So they want this, right? They want this over this. Okay, so again, that was the first case where we ignored this. So we need FG over GB. Okay, we need FG over GB. Okay, but remember, we also do know FG. Sorry, FB. FB was 5K. Okay, so essentially what we're going to have to do is we're going to have to work out GB, and we're going to have to work out FG. Okay, because then that will give us then this BC over CD. Okay, so that's our main goal. We need, I'll write that down for us, right? We need FG and we need GB. Okay, this is our goal. We need to find this, right? We need to be detectives and we need to find this. Okay, so remember, if you're stuck, you ask yourself, what do I need? How do I find it? Okay, so step 1, we found out what we need. Step 2, what we're going to be writing over here is, how do I find it? Okay, so we need to be thinking that. Okay, so how can I find FG and GB? Okay, so let's have a think. Okay, so again, if we ignore this bit and this bit, right, we can work out, we know that FG is here and AF is here, but we also have this side in proportion, right? So let me use orange here for the right. Okay, let me get rid of this. Let me get rid of this in red. Okay, this little triangle here. Okay, I'll fix this in a sec. Let me also get rid of the green. Okay, so I'm just scratching this out so you can see the triangles we're working with easier. Okay, so we're working with these two triangles here and this side in proportion. Okay, so if we have a look at that, we can say we are working in triangle ACG, right? So remember, this was 3P and this was 2P. Okay, and again, we knew what AF was. So AF we called 2K. Okay, and that came from here. Okay, so again, what are we looking for? We're looking for FG. So we need to find this. Okay, but let's have a look. So it's a good habit to write the triangle we're working with. So we're working with this big triangle, right? ACG. Okay, so in triangle ACG. Okay, in that triangle, what do we have? We have that AE over EC is equal to AF over FG. Okay, and that is from line parallel one side triangle. Line parallel one side triangle. One side of triangle. All right, so we have that. Perfect. So let's fill in what we know. So we have AE is 3P, EC is 2P, AF we know is 2K, and FG is what we're trying to find. Okay, remember, FG is what we're trying to find over here. Okay, so if we do algebra, we can essentially cross multiply. Yeah, so if I show you the algebra steps, so let's cross multiply. So these are going to cancel, right? So we're going to get 3FG is equal to 4K. All right, we're cross multiplying. So these p's fall away, and then this times here and that times there. Okay, so you can clearly see here that FG, we can say therefore FG is equal to 4 over 3K. All right, so first thing done, we have FG. Perfect, we have FG. Now what do we need? We need GB. Okay, so we need to be asking ourselves now, okay, let me get rid of all this shenanigans and let me fill in my information here. I know that FG is 4 over 3K. All right, I'd recommend writing this as 4 over 3 and not this in the calculator. If I do 4 divided by 3. The reason is because this is rounded, right? So you can see it's 1,33. Leave it as a fraction. Okay, so we don't want to be rounding there. Okay. So anyways, we're stuck here. I need GB. I need this. I need this thing over here. Okay, but that's easy to find, right? Because I know that GB is going to be 5k minus 4 over 3, right? So I have that GB is equal to 5k minus 4 over 3k. And that, what is that? If I put that in the calculator, I'm going to get 5 minus 4 over 3. That gives me 11 over 3k. Okay, 11 over 3k. So I have my two things. So that's perfect. Now I can just get into, I'm going to be working here. Now I can just get into this ratio. So let me fill in this. This is 11 over 3k. All right, so I'm just going to be getting rid of this, okay? Because now, again, they're asking for BC over CD. Okay, so they're asking for BC over CD. Okay, so let's say what triangle I'm working in. I'm working within triangle BDF. Okay, the big triangle, BDF. Okay. So when I'm working in that triangle, what we have is FG over GB is equal to, no, sorry, it needs to be the other way around, right? It needs to be the other way around. So let me actually start with BC over CD, okay? So BC is this thing over here, BC over CD. So BC correlates to 11 over 3k. 11 over 3k over, and then CD over here correlates with what? 4 over 3k. 4 over 3k. All right, so I know that these are going to cancel, and then what I can do in my calculator is I can just put that directly. All right, so what I'm going to do is I'm going to say 11 over 3 divided by 4 over 3. Okay, so you can put it like this, and you get 11 over 4. Okay, so let me show you. You could also do this. 11 over 3, right? And then this whole thing is over 4 over 3. You'll get the same answer, 11 over 4. Okay, so what we have then, therefore, BC over CD is equal to 11 over 4. Okay, and what I should have said here is line parallel one side triangle. Okay, I always forget this reason, one side of triangle. Okay. One thing before we move on, I just want to show you how I knew CB. So I knew CB or BC, right? So I knew BC correlated with 11 over 3k, right? That's why it was on the top. And then CD, right? CD over here correlated with 4 over 3k. Okay, so I hope that made sense over there. Cool. Let's move over to question 10. All right, so they give us this hectic funny thing, and they say if f is a single trigonometric function, and they give all of this shenanigans is equal to af is a function of theta, so f is a function of theta, determine the constant a and the trigonometric function f of theta, right? Function of theta. So a lot going on over there, but essentially when you've seen this before, you just simplify this thing. Okay, you just simplify this thing, and it needs to become a single trig function. Okay, so this question is very wordy, but don't let that bug us over there. Okay, so essentially what we need to do is we just need to be simplifying this thing over here. Okay, so let's sort this out, right? So sine theta stays sine theta. Cos 2 theta has 3 options, right? Let me show you the 3 options from our formula sheet. So yeah, so this thing has 3 options over here. It can be either this, this, or this, okay? And well, we can't exactly see which one it needs to be right now, okay? It's not clear which one it needs to be. We don't know which one is going to help make our lives easier, okay? So let's not choose one of them. Let's not choose one of them right now. Let's keep an eye out on it, and then maybe later it will be more obvious which one of those we need to choose, okay? Anyways, then let's do this over sine 2 theta. Well, sine 2 theta actually is a bit of an easier one to do because it only has one reduction, right? It's just 2 sine theta cos theta. So let's do that one. because it has the added benefit of this cancelling with this. Okay, that makes our lives easier. Okay, now let us go over here, and we're dividing by this thing over here. So tan theta has one reduction, or one identity slash simplification. It's just this, right? Okay, minus, and then 1 over tan theta is just cos theta over sine theta. It's just that. Okay, that was our first step. Now let us continue. All right, so I'm going to be cancelling these. Okay, so what we have is cos 2 theta over 2 cos theta, all right, cos theta, and then dividing by, what we need to do here is, it's not really clear what to do here, but let's get this thing together, right? Because right now it's separated by this minus. Let's simplify it by making it smaller, putting it together. Okay, so what we're going to do here is we're going to LCD. Okay, so the LCD is sine theta cos theta. Okay, so if we look here, this thing is missing sine theta, so the top needs to be multiplied by sine theta. So we're going to get sine squared theta. Okay, we keep our sine over there, so I mean negative sine, and over here the denominator is missing a cos theta, so we multiply the numerator thing at the top by cos theta, so we get cos squared theta. Okay, so now this thing was kind of far apart, this thing over here, we've now squished it together a bit. Okay, so we've done that, right? But now it's important, we need to ask ourselves, did that make our lives easier? Let me use a different color. Did this thing make our lives easier? Sine squared theta minus cos squared theta, right? If it's sine squared theta plus cos squared theta, then that's equal to 1. But we don't have that. Okay, and we can't take out a negative to sort that out. Okay, that won't work. So let's think, what is the issue here? Have a look at this, right? If we have cos squared theta minus sine squared theta, then that's equal to cos squared theta. Okay, and that's going to help us because that's going to make this thing smaller. Okay, but the issue is we don't have it in this order. So what we need to do is we need to take out a negative to then get it in that form. Okay, we need to take out a negative to get it in that form. So essentially what we have is it's going to be cos 2 theta over 2 cos theta divided by, and this is just going to be negative cos 2 theta. Okay, negative cos 2 theta over sine theta times by cos theta. Okay, so I hope that makes sense over there. Okay, because I'll show it, if we take out a negative in front, what we're going to do is we're just going to get cos squared theta minus sine squared theta. Okay, if we take out a negative over here. Okay, and then this thing is just that. Okay, but with a negative in front. Okay, so what can we do now? Well, we've made everything smaller and we're dividing. Okay, so we can just tip in times. Okay, tip in times. So we have cos 2 theta over 2 cos theta times by, and remember we're tip and timesing, so it's negative sine theta cos theta over cos 2 theta. All right, now things should be cancelling, right? Because remember we're looking for a single trig function. Okay, so if we chose the right options and if we did the right steps, things should start cancelling, right? And this is exactly what we were expecting. Okay, we were expecting some things to cancel. So these things cancel. Perfect, glorious. This cancels. Now what are we left with? Just a single trig ratio, which is excellent, right? That is just negative a half sine theta. Negative a half theta. Okay, a negative a half sine theta rather. So there you go. We have a single trigonometric function. Okay, so what we have is, you can leave your answer like this, but you can also say, well, therefore a is equal to negative a half, and this function of theta is just sine theta. Sine theta. Okay, because remember this was a f of theta over here. Now for question 2, we have to determine the values of theta as an element, so theta from 0 to 360, for which the identity in A1 is not valid. Okay, So essentially they want a specific solution, and when they say not valid, remember when something is not valid, that means we're dividing by 0. Okay, so we're not allowed to divide by 0. Okay, so let's have a look at this. Okay, so we need to start here. We can't just look at the end. Okay, we can't just look at the end. Okay, we need to look here, and where are we dividing by 0? Okay, so we'd be dividing by 0 if sine of 2 theta is equal to 0. Okay, that is not allowed. That will mean we are not valid. Okay, but very important. Okay, remember here we're dividing. Here's the divide sign by this. Okay, so this thing cannot be 0, because if it's 0, then the identity is not going to be valid. Okay, so we need to check sine 2 theta is equal to 0, and then we're also going to have to check that tan theta minus 1 over tan theta is equal to 0. Then it will be not valid. Not valid. Okay, so let's check these two independently. Okay, so sine 2 theta, so I'm going to be using what they call the graphical method. So yeah, sine 2 theta is equal to 0, so that just means what we're going to have is our angle 2 theta is equal to sine negative 1 of 0 degrees, not 0 degrees, sorry, of 0, plus k times 360. Okay, k is element of integers. Okay, so I'll do this one next. Okay, so I'll first check sine 2 theta, and then I'll do the next, I'll check that other one. Okay, so I have this, but then I also, for sine 2 theta, I need to be saying, or 2 theta is equal to 180 degrees minus sine minus 1 of 0 plus k 360, k times 360, and then again k is the element of integers. All right, so if I bring out the calculator and I do sine negative 1 sine of 0, I get 0 degrees. Okay, so essentially here I get theta is equal to k times 180. Okay, because remember here I have 2 theta, I need to solve for theta. Okay, so divide by 2. Okay, and remember this just gave me 0. Okay, and then k is the element of integers. Bit ridiculous how we need to keep writing this, but let's just do it proper. Okay, then over here we're going to get theta is equal to, so remember sine minus 1 of 0 is 0, so this is 180 minus 0, which is just 180, but we divide by 2, so that is 90 degrees plus k 360, sorry, k 180. Okay, k is the element of integers. Okay, so we have this. Now let's see for our specific solutions when it's not valid. Okay, so it's going to be not valid for, okay, and here we're just going to be putting in different values for k, right? So over here, if we have k is 0, we're going to get 0 degrees, which is, yeah, so which is, it lies in this interval. Okay, so we get 0 degrees, and then over here, if we keep going, we're going to get, if k is now 1, we're going to get 180, right? So 180, and then if k is 2, we get 360. Okay, then let's look at this one. If k is 0, we get 90 degrees. Okay, so over there 90. All right, now let's see if k is 1, so that's going to be 180 times 1, okay, or just 180, so 270. Okay, and then if we then do 180 times 2, we're going to fall outside of the interval, okay, out of this 360. Okay, so that is all the things that sine 2 theta is not valid for. Okay, but we also need to check, where was it? This part again. Okay, so we need to be checking where tan theta minus 1 over tan theta is equal to 0. We need to check that. Okay, so I can just multiply by my LCD, which is tan theta. So I'm going to be getting tan squared theta minus 1 is equal to 0. Okay, so I get tan squared theta is equal to 1. Now what I do is I take the square root of both sides. Okay, but remember when I take the square root, it's plus or minus 1. Okay, very important here, very important. So my two options are I get tan theta is equal to 1 or tan theta is equal to -1. That is when I will be not valid. Okay, so let's move over to a new slide. So if we look at tan theta is equal to 1, okay, we get theta is equal to tan -1 of 1 plus k180. Remember k180 because we're working with tan now, okay, and k is an element of integers. Let me double back that, integers. Okay, I know my double back z's are very messy, but yeah, something like that. Okay, k is the element of integers. So yeah, that's for that over there. And then remember on this side we also had tan theta is equal to -1. Okay, well, sorry, let me finish this one. Okay, so if I do in the calculator, if I do tan -1 of 1, I get 45 degrees. Okay, so essentially this, I get theta is equal to 45 degrees plus k180. Okay, k is element of integers. And then if I work with this one over here, I'm going to be at theta is equal to tan -1 of -1 plus k180. Okay, and k is element of integers. So theta is equal to, and then tan -1 of -1 is equal to -45. Okay, so that's -45 degrees plus k180. K is element of integers. Okay, so let's look at the specific solutions here. Okay, so both of these are not valid for. Okay, then let's look what they're not valid for. So we're going to be substituting in k over here. Okay, so if k is 0, we get 45 over there. If k is 1, we get 180. Okay, so essentially there we get 45 plus 180. Okay, which is 225. So that goes over there, it fits in our interval. And now let's see if we do 180 times 2, we fall outside of the 360 interval. Okay, because let me just remind you guys, we're looking for 0 to 360. Okay, so we've checked this one. Now let's check these. Okay, so if we do, now we're dealing with -45. Okay, so if we do -45, we know that's going to fall out of our interval because it's going to be left of 0, which isn't allowed. But let's see if we do -45 plus 180, we get 135, which definitely falls within our interval. Okay, then what happens if we do -45 times 180 times 2? If our k is 2, well, we get 315, which falls in our interval. Okay, and the next one you should notice isn't going to fall in the interval, but if we times it by 3 to check, yeah, it falls outside. Okay, so it is not valid for all of these. Okay, so the answer is not valid for all of these answers. So 0, 180, 360, 90 to 70. Okay, so I'm just checking with the memo. We have 0, we have 180, we have 360, we have 90 and 270. Perfect. And then we have 45, 135, 225, 315. Okay, perfect. So we've covered all the bases over there. Okay, cool. So I hope that made sense over there. Okay, cool. Now for B over here, they say ACD represents a horizontal triangular field. So this is our horizontal plane. And BD represents a vertical building. So these are 90 over here. And they say AC is 120 meters. So here we have 120. DAC is alpha, that's given. ACD is beta, that's given over there, or beta, however you want to say it. And it's kind of like a data debate, I guess. And then they say the angle of elevation of B from A is theta over here. All right, so that's all the information there. Let's just make sure we know that this is 120. they say determine the height of building BD in terms of alpha, beta, and theta. Simplify your answer. Okay, so important, we need to simplify our answer. Okay, so we need this height BD. Okay, so we need this height BD over here. So let's see what we can do, right? So let's work with BD. So if we want to find BD, and we have this angle on a 90-degree triangle, we have that, we're going to have that, what are we going to do? We can look at cos theta is equal to our opposite. Okay, so if you do cos theta, you're going to be looking at your adjacent, which is AD, over hypotenuse, which is AB. Okay, but we don't know AB. And remember, we're trying to include something that has BD. Okay, so essentially here, we need some ratio. Okay, so AD we can find because we have enough information down here, right? And remember, we're trying to include alpha and beta. Okay, so we need to find BD, we need to mention AD. Okay, so you can see here from theta's point, this is our adjacent and this is our opposite. Okay, so we're going to have to be doing tan theta is equal to BD, which we're trying to solve, over AD, which we can solve. Okay, we can find AD by looking down here. Okay, so our main goal now is find AD. All right, because then that'll give us BD using that tan theta. All right, so AD, we can use the sine rule, right? So AD over sine beta is going to be the same as this angle, sorry, this side, 120 over sine of this angle. Okay, let me rather work here. Sine of this angle, okay. Because remember, I'm trying to find AD. So I'm going to be using the sine rule over here. So I'm going to be mentioning this, but also I'm going to be working here. Okay, so I'm working there and there. So the thing is, I need to find this angle over here. I need to find angle ADC. Angle ADC, okay? But I know this. I know that angle ADC, right, plus alpha plus beta is equal to 180 degrees, right? And that's just from interior angles in a triangle. Okay, so what I get then is ADC is equal to 180 degrees minus alpha minus beta. Okay, but I can put that together as 180 degrees minus alpha plus beta. Okay, so I have that, right? So now let me apply the sine rule, and what I have is AD over sine beta, okay, because I'm working here now. AD over sine beta is going to be equal to 120 over, right, because we're dealing 120 over sine of this angle, and remember that angle's over here. Okay, so that's over sine 180 degrees minus alpha plus beta. Okay, let me use a square bracket over there. Okay, cool. So I have that, and let me actually simplify this, okay, because this is just in the second quadrant and sine is positive there. Okay, so essentially what I get is AD over sine beta is equal to 120 over sine alpha plus beta. Alpha plus beta. Cool. So I have that over there. So now I just make AD the subject of the formula. So AD is equal to 120 times sine beta over alpha plus beta. Okay, sine of alpha plus beta. Okay, so I have AD over here. Now I just need to look in this triangle to then find BD. Okay, so let's move to a new slide. Okay, so again, now I'm just going to be doing tan of this angle is my opposite over my adjacent. Okay, so I have tan of theta is equal to my opposite, which was BD, over my adjacent over here, which is AD, over AD. Okay, so what I could do now is I could fill in AD as this thing, but it'll be a bit messy. Okay, so first let me make BD the subject of the formula. So I'm going to get that BD is equal to AD, all right, times by tan theta. Now let me fill in AD. Okay, because AD is this whole thing over here, this thing over here. So that is going to be 120 times by sine beta, or 120 sine beta times by tan theta, right, all over sine alpha plus beta, sine of alpha plus beta. All right, so I have this, okay, for BD, but interesting enough, this isn't enough for the memo. So the memo wants you to simplify this out, okay? So what I mean by that is we're gonna have to be using this. I'm gonna have to be using one of these, okay? I cut out the left a picture, okay, it's actually fine. Yeah, we're gonna have to be using one of these, and you can see that this thing over here matches perfectly with that. Okay, so technically we're not done here yet, okay, even though BD is now just in terms of alpha, beta, and theta. Okay, we actually need to expand this out. So that's 120 sine beta tan theta over, and now this just becomes sine alpha cos beta plus cos alpha times sine beta. Okay, and that is how we would do that question over there. Let's move over to question 11. So here in the diagram, they say triangle ABC is drawn with A. They give the coordinates here of A. They give the coordinates of B. They say D is the center of the circle. So here's D. It's the center of the circle. Very important. So what does that make DF? That makes DF a radius. Okay, that's an important fact. And again, we could construct another radius over here, which could be helpful. All right, so always be thinking when they give you information. All right, and they say ADC cuts the circle at F. Okay, here's ADC, cuts the circle at F with AF, this line over here, being equal to FD, that segment over there. Okay, but they did show us that. That's probably important information, so let's not forget this. And they say E is a point on the circle, so that CE is a tangent to the circle at E. Very important, okay. So this is a tangent. Okay, so if I draw this, if I draw radius DE, I know that this is 90 degrees. Okay, because again, radius is perpendicular to our tangent. Okay, that could be helpful. So let me even draw that in. Okay, and then they also tell me that BC is perpendicular to AB. Okay, so here's BC perpendicular to AB. All right, so a lot going on here, but let's think. What section of work are we in? Analytical geometry, right? Okay, analytical geometry, a lot of the time what we're dealing with is gradients, right? We're dealing with gradients. Okay, and when we have perpendicular lines like this, we know that the gradients are negative inverses of each other. Okay, so one thing I want you to keep in mind is that the gradient of AB times by the gradient of BC is equal to -1. Why? Because they're perpendicular. We might have to use that fact. Okay, so again, you see how many times we're analyzing the question before we're even looking at what they want. Okay, we're trying to get as much information as we can and thinking as much before we get into the problem. Okay, so we have as much information as we can have before we start going into the problem. Okay, so let us have a look. They say determine the equation of the circle with center D. Okay, equation of the circle with center D. So let's start off by just listing this, right? This is pretty easy, right? So that's just y minus 5 squared is equal to r squared. Okay, that's nice and easy, okay? Because they gave us the center of the circle, the coordinates for the center. So we have this, but now our main problem is, well, okay, how do we find r squared? Okay, so we need the radius, but remember df is a radius. This is a radius, okay? So we might be thinking, okay, how do I find the length df? Okay, but df is equal to fa, right? So, but then how do I find fa? I can't really find fa, but what I can find is ad. I can find the length of AD because I can apply the distance formula. Okay, so if I have AD, I just half it to find DF, which is my radius. Okay, so let me find AD. Okay, so AD is going to be equal to the square root of -2 plus 4 squared plus -1 minus 5 squared. Okay, so AD is going to be equal to, so this is going to be 2 squared, which is 4, and this is 6 squared, which is 36, so it's square root 40 units. Okay, so AD is equal to the square root of square root 40 units. Okay, so we have that, and then so what we can say is, well, therefore, well, we can say that well, yeah, we can literally just say, well, therefore df is equal to half of this. Okay, so let me actually put this in the calculator. So square root of 40. All right, so we could have wrote 2 root 10 over here to simplify, but the square root 40 is fine. So what we do is we take this answer and divide it by 2. So that's just going to be root 10. Okay, root 10. So we know df is equal to root 10 units. Okay, so what we have then is, and we know that df is 10 units because it was given, the reason here, it was given that AF is equal to FD. Okay, that was the reason over there. Okay, so we have that, so we can say that therefore the radius is root 10 units. Okay, so therefore r squared is equal to 10. Okay, so the equation of the circle then is, therefore equation of circle is this. It's going to be x plus 4 squared plus y minus 5 squared is equal to 10. Okay, that is the equation of the circle. Okay, another thing you could have done is you could have worked out the coordinates of f being a midpoint. Okay, f is the midpoint of dA. Is it dA? Yeah, f is the midpoint of dA over here. Okay, then if you have the coordinates of f, you can then substitute it in over here to then find r squared. Okay, so you could have done that. I preferred to do this one. Okay, but you do come to the same answer, so no problems with whichever method you do choose over there. Okay, then we got a bit of a hefty question over here for 7 marks. Determine the coordinates of C. Okay, so let's go back to our big diagram. Determine the coordinates of C. All right, so we need to ask ourselves 2 things. What do I need? How do I find it? All right, so obviously what do I need? I need the coordinates of C. Okay, but how do we find that? So we can ask ourselves, what's special about C? Okay, what I see special about C is that it's the point of intersection of this line and this line. Okay, the point of intersection of these 2 lines. Okay, so now I have, what do I need? I need the equation of this line AC, and I need the equation of line BC. All right, so I know I need those 2 things. So I'll ask myself, what do I need? What do I need? Okay, and it's the equation of AC and equation of BC. Okay, these are the 2 things I need to solve the problem. And then how do I find? Okay, so how I'll find. Okay, so finding the equation of AC is quite easy, right? Because we know we can find the gradient AD and then we can substitute a point. Okay, so that's almost trivial, so we can find this, right? Finding BC is a bit more difficult. Okay, so the thing is, we have a point on BC, but we need the gradient of this line, right? So now a bit of a subsection is, we're asking, what do I need? Well, I need this now. This is what I need. How do I find it? Have a look at this, right? Here, I need BC, okay, so I need this, right? So I need this. This is my question mark. This is what I need, okay? So how do I find that? Well, I need this. So now this is the thing I need. But how do I find the gradient of AB? That's quite easy. Okay, we just can use our normal gradient formula over here. Okay, so do you see how you need to break down this problem in your mind? Okay, and a lot of students have a good intuitive feel for that. Okay, by doing enough practice or just being mathematically inclined. But if you struggle with that sort of logical step-by-step thinking, go through this process. okay, like I went through this now. Okay, I recommend, if this was confusing for you, I recommend rewatching this last little bit where I went through these steps. What do I need? How do I find it? Okay, maths becomes a lot easier if you can do this. Okay, if you can do these steps. In the beginning, it's tough, all right, but once you practice enough questions and you get exposed to enough problems, it becomes easier, okay, because you get enough experience with problems, and these techniques are repeated, okay, where you have to find equations and things like that. Okay, but yes, what do I need? How do I find it? It will help you so much in maths. Okay, what do I need? How do I find it? Okay, let us get into it then. So we need the equation of line AD. Okay, so let's say line AD and line AC are the same thing. So anyways, line AC, well, if we look at the gradient of AC, that is just going to be equal to 5 minus -1 over -4 minus -2. All right, so what do we get there? We get 6 over -2. So what is that? That's just -3. Is that correct? What is that? That looks a bit off. No, that's right. Really? Yeah. Okay, so it's 6 over -2. Yeah. Okay, so we have our gradient of AC. So what we have then is y is equal to -3x plus c. Okay, so what we do now is we can just sub in a coordinate. Let's just sub in -4, 5. Okay, so we get 5 is equal to -3 minus 4 plus c. So this is 12. Take it across the other side is 5 minus 12. So c is equal to -7. Okay, so for line AC, okay, here we have the equation of AC is given by y is equal to -3x minus 7. Okay, now we have that. Now we need, well, let me go to a new slide. We need the equation of line, so not even the equation, we just need the gradient of line AB. Okay, so I can actually do that here. Okay, so for the equation of, well, the gradient of AB is just going to be -1 minus 3 over -2 plus 10. Okay, that gives me -4 over 8, which is just -0.5. Okay, that's the gradient of AB. Okay, so therefore the gradient of BC is equal to 2. All right, and that's because BC is perpendicular to AB. Okay, cool. Now I'll continue over here. Let's say we're working now with line BC. Okay, we're working with line BC, and for line BC we have that y is equal to 2x plus c. What we can do now is we can substitute in point -10, 3. So what we do then is we get 3 is equal to 2 times -20 plus c. So that becomes +20 when it goes to this side, so c equals 23. Okay, so the equation of BC is then given by this. Y is equal to 2x plus 23. Okay, so I have the equation of this line, I have the equation of this line. To then find the x coordinate of that, I just set the two lines equal to each other, which I will do here. Okay, so what we're going to get is, whoops, we're going to get 2x plus 23. All right, so that's for BC. Okay, and that's going to, then we need to set that equal to line AC, which is here. It's equal to -3x minus 7. Okay, now from here it's just algebra. So 5x is equal to -30. So x is equal to -6. Ask ourselves, does that make sense? Are we expecting a negative coordinate for C? And we are, because we're to the left of the y-axis. And here was -10 and here was -2. So this will be somewhere in the middle, okay? Middle-ish. Okay, so here we have the x part of the coordinate of C. So to find the y coordinates, we just substitute it in either there or there. Okay, so it'll probably be easier to sub it in over here. So we say y is equal to 2 times -6 plus 23. So that is -12 plus 23, which is just, what is that, 11. Okay, so very important, they asked us what? The coordinates of C. Okay, so put it all together. So therefore C is the coordinate -6, 11. Okay, so does that make sense? Were we expecting a positive y value? Yes, we were. And 11, yeah, because this was 5, that should be above 5. Okay, 11 seems about right. Cool. And then moving over to question C, further confirming that our C was right, was this. They say, given that the coordinates of C is this. Okay, so they do tell us what our C was over here. So we knew we were right. So now they say determine the length of tangent CE if it is given, if the coordinates of C is given. All right, so let's go back to our big diagram. Okay, and let's see, they want the length of this tangent CE. They want this, they want the length of this CE. Let's just confirm. Yeah, they want the length of tangent CE. All right, but remember, we know that this is 90. We know that that is 90. All right. So what we could do is we could do Pythag. All right. But the problem with Pythag, well, let me fill in this. We know it's -6, 11. We could do Pythag because we could work out the length of CD. But the thing is, we can't really find the length of DE. Ah, okay. But we do know the length of DE. So the thing is, we can't apply the distance formula to DE because we don't know the coordinates of E. Okay, but we know DE is what? DE is a radius. So DE is going to be equal to DF. And we've already found DF over here. Okay, so we can apply Pythag. Where was I here? We can apply Pythag. Okay, so we have this distance and we can find distance DC by using the distance formula. Okay, so let us find distance DC. Okay, so distance DC is going to be the square root of -6 plus 4 squared plus, where are we, 11 minus 5 squared. Cool, so that's going to give us -2 plus 6, sorry, 2 squared plus 6 squared. So that's again square root of 40. All right, so CD is square root of 40 units, okay, which is just 2 root 10. Okay, but I'm going to leave it as, yeah, I mean, you could put in the calculator. I just did it in my head over there, but you could, yeah, if you do put it in the calculator, you will find that, again, I did it in my head, but if you do it in the calculator, you will find the calculator gives you the simplified answer of 2 root 10. But 2 root 10 is the exact same as square root of 40. Okay, you can see over there. They are exactly the same. All right, so I can leave it like this, no problem. So if we go back, I know that then this is square root of 40 and DE, I need to be saying what the distance of DE is, right? But I can say that DE is equal to DF, right? And the reason, and I know what DF is, DF was root 10 units. Where did I get that? I got it over here. Okay, I need a reason for this, and that's radii. Okay, my reason is radii. All right, now I need to be saying that this is 90. Okay, the reason I need to say this is 90 because I'm applying Pythag. Okay, so what I'm going to be saying is line DE is perpendicular to line EC, and the reason there is radius perpendicular to tangent, so rad perpendicular to tangent. Okay, so what I can do is I can apply Pythag now, right? So I'm going to be having that, again, if we look in the big one, CE is going to be equal to root 40 minus root 10. Okay, those things squared. Okay, so I'm going to get CE squared is equal to root 40 squared, well, which is just 40, minus root 10 squared, which is just 10. Okay, so I get CE is equal to the square root of 30. Okay, it's 30 units. Okay, so I could check in the calculator if that does simplify. Square root 30 units, whoops, 30 units. It doesn't simplify, but even if it did, it's not the end of the world. You can just leave your answer like this. So there we have it. That was that question over there. Okay, moving over to question 12. They say the equation of a circle with center P is given as. Okay, so they give us the equation, and then they say determine the center and radius of the circle with center P. Okay, so here we're just going to have to complete the square. All right, so to complete the square, we're going to have x, and then here we keep the sign, minus, and then we half this, 14 halved is 7. We square this. What have we just created? We've created a positive 49, because if we square this negative 7, right? If we square this, we're going to get positive 49. So let's take away 49 on this side. Okay, plus y, the sign here is minus. Half of 2 is 1. We square that. What have we just created? If we square negative 1, well, we create positive 1. So we need to take that away. All right, and then on the right we have negative 46. Cool. So let's see what we have here. On the left, we just have this, okay? And now we take all the constants to the other side, so it's going to be negative 46 plus 50, okay, which is just 4, positive 4, which is equal to 4, okay? But remember, 4 is just equal to 2 squared, okay? So therefore, center P, the coordinate of center P is 7, 1, and they want the radius. Radius is equal to 2. Okay, the radius is equal to 2. Cool, not too bad. They say that this point lies on the circle. This point lies on the circle. Determine the equation of the tangent to the circle at A. Okay, interesting. So we need the equation of the tangent to the circle at A. Okay, so we have a point. All right, so remember, when we want an equation of a straight line, we need a point and the gradient. So we need the equation of this gradient. Okay, sorry, not the equation. We need the gradient. I don't know what I think we said. I said equation of gradient. We need the tangent. We need the gradient of the tangent. I'll say that again. We have a point on the tangent, so we need the gradient of the tangent. Okay, because for a straight line you need two things. You need a gradient and you need a point. Cool. We have a point, we need the gradient. Okay, so what do I need? I need the gradient of the tangent. This is what I need. All right, but I know that the gradient of, well, I know this. I know the tangent. Well, I know radius is perpendicular to tangent. Okay, so that means that my radius is, what I can do is I can apply this. The gradient of the tangent times by the gradient of the radius is equal to -1, because they're perpendicular. Okay, so let me find out what the gradient of my radius is, right? Because let's have a look. We have a circle. That's, oh, they're not getting better. There we go, it's a bit better. Okay, so here it has center P. All right, then somewhere we have some coordinate A. All right, so we know that we can work out this this gradient, because we have the coordinates of P and the coordinates of A are given over here. Okay, and we know PA is a radius, okay, because this is a center, this is on the circumference. Okay, and then somewhere over here we have a tangent. Okay, we have some tangent that goes through like this, but we know that this is 90. Okay, and we know the tangent goes through this point A. So if we can work out this gradient, then we'll have this gradient of the tangent. Okay, so let's work out the gradient of PA. All right, so remember the coordinates of P is 7, 1. Okay, I'll put it up here for 7, 1 is P. Okay, so our gradient is going to be 1 minus root 3 plus 1 over 7 minus 6. Okay, so that is going to give us, if we go over to the calculator, that's going to give us at the top 1 minus root 3 plus 1. Okay, make sure that plus 1 is outside of the square root. Okay, so that gives us negative root 3. Okay, so I know the bottom gives me 1, so I know my gradient is just negative root 3. Okay, so I can have then that, therefore, the gradient of the tangent is going to be equal to the negative inverse, which is just 1 over root 1 over root 3. Okay, you can apply this. You can apply that PA times gradient of the tangent is equal to -1. Okay, so they're just negative inverses of each other. So you can check using this, but yeah, they're just negative inverses. Okay, and the reason this is true is because radius is perpendicular to tangent. Okay, is perpendicular to tangent. All right, so what I have now is I have y is equal to 1 over root 3x plus c. Okay, because we're working with the equation of the tangent. So what I do now is I just sub in this point that lies on the tangent. Okay, so be careful, we're subbing in A, not P. Okay, because the tangent goes through A, not P. Cool, so we're subbing in 6 root 3 plus 1. Okay, so we get root 3 plus 1 is equal to 1 over root 3 times 6 plus c. Okay, so c is going to be equal to, if we move over to the calculator, I'm going to get root 3 plus 1, and then this thing is going to be minused by 1 over root 3. 1 over root 3 times 6. Okay, because when this goes across, it'll be a minus. So for c, I get this, 1 minus root 3. Okay, 1 minus root 3. So c is equal to 1 minus root 3. Okay, so we can say that therefore the equation of tangent is this. It's going to be y is equal to 1 over root 3x plus 1 minus root 3. Okay, because remember it's plus c, and this thing is my c. Okay, so that would be the equation of my tangent. We might need this in the next question, right? Because there is a part c over here, so let's consider that. Okay, we don't actually, yeah, we might need it. Okay, we might need it. Okay, now they say consider this point, consider point B. Does the point lie on the circle? Explain. Okay, so what is the equation of our circle? It's this, right? So if I substitute this point in, right, because remember this is an x, right? This thing is my x, and then this thing over here is my y. Okay, so if I substitute an x and a y in here, what am I expecting? I'm expecting 4. If that is not true, the point will not lie on the circle. Okay, so what I do is I literally just substitute this in. I'm going to get 8 minus 7 squared. Okay, because we're using this equation of the circle. Let me actually put this in. Let me bring this up for us. Okay, the equation of the circle over there. Cool. So we have that. So if we're looking at the left hand side, we get this plus y is negative root 3 plus 1 minus 1 squared. Okay, so we need to evaluate this in our calculator. So we're going to get 8 minus 7 squared plus minus root 3 plus 1 minus 1 just falls away, squared. And we get 4. Okay, and this is equal to 4. Okay, so right, we can say that this is the left hand side. Okay, and yeah, we can say that left hand side is equal to right hand side, all right, because our right hand side is this 4. Okay, so therefore point lies on circle. The point lies on circle. Cool. All right, we just substituted these coordinates in over there. Okay, and now they say, is AB the diameter of the circle? Explain. All right, so a diameter, what is the diameter of a circle? Okay, the diameter of a circle is 2 times the radius. Okay, so diameter is 2 times the radius. What is our radius? 2. Okay, so we need, for the diameter, we need to get the diameter of 4. So the distance AB has to be how many units? 4, for it to be a diameter. Okay, so let's test that. Let's find out the distance AB. Okay, So the distance of AB, so the coordinates of A was given here, 6 root 3 plus 1. So I'll write it up here for us. Well, rather here, 6 and root 3 plus 1. Let me just confirm that. Yes, perfect. Okay. So if we work out this distance, it's going to be 8 minus 6 squared plus, and what we're going to be having is root 3 plus 1 wait, I didn't write the plus 1, so let me do this in square brackets, minus root 3 plus 1. Okay, and then this whole thing squared. Okay, so we need to be careful with how we apply that, right? Because this comes from B, right? So this is B over here, and then this is the y coordinate, right, of A, and this comes from A. So we need to minus that. Okay, so be careful. Don't just write minus 3 plus 1. Okay, it's actually going to be minus root 3 minus 1. Okay, be careful with that. So, but what we can do is literally just shove all of this in the calculator. I'll show you how to do that. So we're going to be doing the square root of 8 minus 6. That's all squared plus, and I'll do a double bracket for us, minus root 3 plus 1, that's the y coordinate of B, minus, now the y coordinate of A is minus 3 plus 1. Okay, what mistake did I make there? The 1 was in the square root. Okay, so it can't be in there, it needs to be like that. Okay, and then this whole thing is squared. Okay, so again, remember, this is the y coordinate of A, that's why it's in a bracket like that. So anyways, when I evaluate this whole thing, I get that the distance AB is equal to 4 units. Okay, so we can say, therefore, AB is a diameter, right? Because the distance is twice the radius. Right, because the distance AB is twice the radius. Okay, it's 2 times the radius, right? And came from this. Okay, that's a 4 with an arrow. Okay, so yeah, the diameter is twice the radius, while AB is twice the radius, so it has to be a diameter. Okay, because both of the points lie on the circumference. Alrighty, cool. Now let's get into the final question of the paper. So they say in diagram below, ABCD is a rectangular base, so that's important, of one section of a roof of a hut in the mountains of Lesotho. The isosceles triangle BEC, so it's isosceles, but they have shown that for us, very nice. And they say it will form one section, will form another section of the roof. So they say AB is 12, so this is 12 because it's rectangular. AD is 8, and EM here is 6, and BE is equal to CE. So this is equal to this. We knew that already because it was isosceles. Then they say in diagram 2 below, triangle BEC from diagram 1 is now folded up along BC such that it's perpendicular to the base ABCD. Okay, so we have that. This thing is now vertical. All right, so let's have a look. So the first question is, it says, when the roof is completed, angle BEC, this angle, needs to be smaller. Okay, it needs to be smaller than 65 degrees to prevent snow building up on the roof. Determine whether or not snow will build up on the roof. Okay, so don't let the English confuse you. This angle here needs to be smaller than 65. Okay, so in the big diagram, this angle here needs to be smaller than 65. Okay, so let's just have a look at this. This BC is also 8. Okay, because it is a rectangle, right? It's a rectangle. All right, so that distance is 8. So we need to find this angle over here, BEC. So a few options we could do is we could do the sine rule. Okay, but to do the sine rule, you're going to need this angle on this side, which is a bit of a mess. Okay, But what we have is if we have one of these sides, right? So let me not do that. If we know this side, if we could somehow show that this side is equal to this side, and that's 4, what we can do is we can just do trig, right? We have our opposite and our adjacent. So we can do trig to find this angle, and it will be double that angle, because if these two triangles are congruent. Okay. So, yes. So we need to prove that these triangles are congruent, okay, which is actually not too hard. Okay, and I see the memo, it doesn't actually require you to go through all of the steps. Okay, it doesn't require you to go through all the steps, but essentially what we need to be saying is triangle BEM is perpendicular, what am I saying today, is congruent to triangle, now we need to be careful, CEM, all right, and the reason there is right angle hypotenuse on side, okay, because they both have 90 degrees. Let's just get rid of this. If we look at these triangles, this is 90, this is 90, the hypotenuse angles are equal and they share a common side, EM. Okay, so they have to be congruent by RHS. All right, so what we have then is what we needed, that BM is equal to MC. Okay, we needed that, right? So if we had to look at what do I need, so I needed this, right? Because I knew this was 6 to then find this angle. Okay, so the reason that this is equal to that, right, and this is 4 centimeters, is due to the reason for that is, again, because these triangles are congruent. So the reason for that is this, that the triangles are congruent. Triangle CEM. All right, so we have that. Cool. So we know that this is 4, this is 6. So now we need to find this angle over here. Okay, so let's say we're working in triangle BEM. Triangle BEM. Okay, if we look in that triangle, we have that tan of angle BEM is equal to our opposite, which is 4, over our adjacent, which is 6. Okay, 4 over 6. Okay, so I can just use my calculator to find angle BEM. Okay, I can use my calculator and I will find that I just do shift tan of 4 over 6, right? And that gives me, to one decimal place, it'll be 33,7. Okay, 33,7 over there. 33,7 degrees. Okay, so that's angle BEM, and well, we can say that, well, therefore angle BEC is equal to double this, right? So let me bring up the calculator again. So angle BEC will just be double our previous answer, okay, which is 67,4 degrees. Okay, it'll be 67,4 degrees. So BEC is equal to 67,4 degrees. All right, so we've got BEC, but now we need to answer this, determine whether or not snow will fall on the roof. Okay, so we need to be smaller than 65. Okay, and we're bigger than that. So what we have to say is, therefore snow will build on roof, will build up on roof, will build up on roof. Okay, because we are not smaller than 65. Okay, cool. There is another alternative to this question. You could have used a cosine rule and Pythag. Okay, that is another thing you could have done. Cool. Now for the final question, this is not the final question, sorry, of the paper. I just see now there's one more. But anyways, okay, for the final, this is the penultimate, the second last question. So the final question of the penultimate question. All right, anyways, we need to find DEC, angle DEC as shown in diagram 2. So if we look at this, so we need this angle, right, DEC. So if we look at this, the front facing triangle, right? So the front facing triangle is actually this. Okay, so it's not along that dotted line over there. Okay, so if we look in this front facing triangle, so let me color in the front facing triangle. So it's this one, right? It's not this one that's dropped down. Okay, it's this front facing triangle. We need this angle. Okay, so we can find this. Let's think, what do I need? I need this angle. How do I find it? Okay, so for me, we don't know any other angle in this triangle. Okay, so the memo does say that this is 90. I don't know how to assume I don't want to assume that's 90. I'm not sure exactly how to show that that is 90 without assuming it. So what I'm going to do is I'm just going to use the cos rule. Okay, because we don't have this angle, we don't have this angle. Okay, let's assume this is 90, which I don't want to do. So we're going to be having to do the cos rule. Okay, so I'm going to need side EC. I can find side EC quite easily because this is 4. So I can just do Python. So side EC is kind of easy. And then I'm going to need side DC. Well, I know what DC is because this is a rectangle. So this is 12. Okay. So I have this side. Now I need side ED. All right. And it's a bit tough to find ED, but I can look in this dotted triangle that they gave me, right? I can look in this dotted triangle. If I look in that triangle, I need, let's get rid of this, right? So if I look in the dotted triangle that they give us, remember I'm trying to find DE, this distance. So I can find DM quite easy, right? Because DM is this thing over here. So I have this as 12, I have this as 4. So I can find DM. I know the distance EM is 6. I know that that is 6, right? So then I can find DE by Pythag. Okay, so let's work with this. So what I'm going to say is we're working in triangle DEM, right? So in that triangle, we have that EM is equal to 6 centimeters. Right? I was going to say units there, but it's given as centimeters, right? So EM is 6 centimeters, that was given, and before we even do that, we need to look in triangle DMC, right? In triangle DMC. All right, because we first need DM, okay? So let's be formal, okay? In triangle DMC. Okay, we're working in this triangle, okay? We have that DM squared. So I know that this is 90. Okay, so let me elaborate. I know that this is 90, okay, because it's a rectangle by definition, okay. So I have that DM squared is equal to 12 squared plus 4 squared, okay. It comes from here, triangle DMC. Okay, so to find DM, therefore DM is equal to, and if I go to my calculator, I do 12 squared, 144, plus 4 squared is 16, what does I get, 160, square root that to get 4 root 10, okay, 4 root 10, so this is 4 root 10 centimeters, okay, so I have DM now, okay, but remember I need to find ED, okay, that was one of the things I needed over there, okay, so now let's move over to triangle DEM, which is where I started the problem, okay. So in that triangle, right, we have EM is 6. We just found DM, so we can find ED, okay, by Pythag again, okay. So ED squared is equal to DM squared, so it's going to be this thing squared, 4 root 10 squared, plus EM is 6 squared. I'll show you again. Here's EM being 6. They tell us EM is 6, okay. And if we put this in the calculator, we're going to get that ED is equal to, if we go to the calculator, we say this on squared plus 6 squared, and then we take our answer and square root it. So we get ED is 14 units. Instead of units, sorry, centimeters. Okay, not so used to working with centimeters in these problems. But anyways, so we now have ED. Okay, we now have ED. Okay, so if we look at this front triangle again, remember we're working with this triangle here. So we need this angle. So we have ED, so we have DC this was 12 from the rectangle. So one thing we still need is EC. Okay, so we need to look in this triangle over here. Okay, let me just get rid of a bunch of this stuff. So we have this is 6, this is 4, we need EC. Okay, because here I need EC. Okay, so if we work now in triangle MEC, what we have is EC squared is equal to 4 squared plus 6 squared. That's from Pythag. So EC is going to be, if we go to calculator, 4 squared plus 6 squared, don't forget the square root, is 2 root 13. Okay, that gives us 2 root 13 centimeters. Okay, so finally, okay, we have this is 12, we have that, what do we have? We have ED, this thing over here, this distance over here is 14. We have that this is 12, and we have that EC is now 2 root 13. 2 root 13. Okay, so now finally we can apply the cos rule. Okay, and then from the cos rule, right, what we're going to have is 12 squared is equal to 14 squared plus 2 root 13 all squared, right, minus 2 times that, and 2 root 13 cos of angle DEC. DEC. Okay, so a lot was going on there, but I'm going to show you how to do this in one step in your calculator. Okay, so we're going to say 12 squared minus 14 squared, all right, minus 2 root 13 squared. Okay, I did that wrong, sorry. It should be like this, squared. Okay, if I get this, right, so that means that these two things have moved to the other side. Okay, let me not do it in one step, it gets a bit hectic. Okay, so essentially then I'm going to get this answer of negative 104. Negative 104 is equal to this, 2 root 13 cos DEC. Okay, so if we continue back in the calculator, we now take this answer and we divide it by what's in front of our cos DEC. So it's negative 2 times 14 times by 2 root 13. Okay, so we're going to get this. We're going to get cos DEC is equal to this. So what we can do is just shift cos of this, and then this will be our angle. Okay, so DEC is going to be 59 degrees. 59 degrees. Okay, sorry, not cos DEC, the angle now, DEC is equal to 59 degrees. Okay, the memo is a lot shorter than my method, but again, I'm not so comfortable with the assumption that this is 90 degrees. If you assume that this was 90, the problem becomes a lot simpler. Okay, the problem becomes a lot simpler. I'm not so comfortable with doing that though. So this is more the full way of doing the problem. Okay, if you weren't too happy with all my calculator steps, try work from here, do the algebra yourself, okay, and see if you can still get to this final problem, final answer over here. Okay, now finally the last question of the paper. Cool. So they say that O represents the origin, A is a point on the line with equation f of x is negative 2x. Okay, so the equation of this line is negative 2x. B is a point on OA, so that OB is 125 units. Okay, here's OB, so square root 125. I said 125, sorry, I mean square root 125. Okay, so we can kind of think a bit of Pythag over here, right? Because we have a right angle triangle here. Something to keep an eye out for. They also say that E is a point on the y-axis, okay, so that EB is perpendicular to OA. All right, that's given over here. Cool, so this is a y-intercept of this line and this line, which could be important. Then they say G, no, they don't say that. They say D is a point on the line with equation g of x is 2x. Okay, so the equation of this line is 2x, and this equation is negative 2x. Okay, and then they say C is a point on the line, C is a point on OD, so that EC is parallel to OA. Alright, so these lines are parallel. Okay, so this looks a bit like analytical geometry, right? So analytical geometry, remember, if lines are parallel, gradients will be equal. Okay, so for example, we know that the gradient of OB is equal to the gradient of EC. This could be important. We also know that the gradient of BE times the gradient of OB is equal to -1. Okay, so we know that, but remember we can replace OB with MEC. Okay, because they're equal. So this might come up as well. Okay, and what else? This is a y-intercept, so it's a y-intercept of these lines. It could be helpful, and we know we can do Pythag in this triangle because this is root 125 units. That could be coming up. So let us have a look. They say determine the coordinates of B. Okay, so B is over here. So interesting question. Let's see how we can tackle that, right? So again, I would say what's special about B? What's special about B? So what I see special about B is the point of intersection between line OA and line EB. So we already know the equation of OB, right? And we know actually the gradient of EB, right? Because the gradient of EB is the negative inverse of this. Okay, so we know the gradient of EB is actually just a half. Okay, so we know quite a bit about EB, about the line. We just need a point. Okay, so, well, they're asking us to find coordinate B, so we need E, right? We need this coordinate E, and that's where we get stuck. Okay. But one thing I forgot to mention is in analytical geometry, we also deal with this, with inclination, right? So tan theta is equal to m. Okay. So interesting. So if I look in this triangle over here, I want to focus on this triangle because my main focus now is I need to get E. I need this coordinate. Okay. So I'm asking, I need coordinate E. How do I find it? So I know this distance here is root 125. Okay, so let me write this big, 125, this distance. Okay, so I need this distance. Okay, the thing is, so I need an angle. I either need this angle or this angle, and then I can do a trig ratio. Okay, so I think, how do I find this angle? And I can find that angle because I can find the inclination. I can find this, the inclination of this line, right? And I know that this is 90 because the x-axis is perpendicular to the y-axis, right? So I can take the inclination minus 90, and if I minus 90, I'll have this angle. So then I'll be able to work out OE, and then I'll be able to find the coordinate of E. Okay, so let's get into that, right? So I'm going to be saying that for this inclination, right, I'm going to be calling, I'll call this theta. Okay, I'll just call that theta. So what I'm going to do is I'm going to have tan theta is equal to, and then the gradient of OB. Okay, but I know the gradient of OB is -2, right? Because the equation of the line is -2x. Okay, so I have this tan theta is equal to -2. Okay, so theta then is going to be equal to, so I'll go on my calculator, I do shift tan of -2, and the answer I get, I just add 180. If it's a negative, I just add 180. Okay, so this angle is, what was that number? It was 116,6. Okay, so theta is equal to 116,6 degrees. Okay, so therefore angle O, not OBE, so it's angle BOE, right? This angle is equal to, and then what I do is I just say 90 minus this answer. Sorry, I say this answer minus 90. Okay, and I get that angle then is 26,6 degrees. Okay, so this angle is 26,6 degrees. Okay, so now I have this angle. I know that this angle is 26,6 degrees. Okay, so if I work in this triangle, I can now find the distance OE by using a trig ratio. So let's say I'm working in triangle OBE. Okay, I'm in this triangle, and when I'm in this triangle, what I'm doing is, what ratio do I need? Okay, because if we look what ratio I need, I have this angle. Okay, this is my hypotenuse and this is my adjacent. So I'm going to use cos. So I'm going to be saying cos of 26,6 degrees is equal to my adjacent, which is root 125, square root 125, over my hypotenuse, which is OE rather, which is what I'm trying to find. Okay, so I get that OE is equal to, and then that's just going to be, if we're in the calculator now, it's just going to be root 125 divided by cos of that angle we had. Okay, so I get that OE is equal to 12,5 units. 12,5 units. Okay, 12,5 units. Right, so now I have the coordinate of E. So therefore, E is the point 0, 12,5. Okay, so I know it is a lot of work. Okay, so we have the coordinate of E now. Okay, and let's keep working over here. So we can say that the gradient of EB, okay, so the gradient of EB, all right, because I'm trying to find the equation of line EB. Okay, so if I need the equation, remember I need two things. I need the gradient and I need a point. I already have my point on the line, I need my gradient. Okay, so the gradient of this line is equal to a half. Okay, and the reason is because OB is perpendicular to EB. Okay, we have that. So what we have now then is, for the equation of this line, so what we can do is we can just write y equals a half x plus c. So technically we know what the c is, we know it's this, okay, but you could sub this point in 0, 12,5, but you're just going to be getting that c is equal to 12,5. Okay, so if we look at the equation of EB, right, so the equation of EB is given then by this, y equals a half x plus 12,5. Okay, now just find the coordinate of B, right, because remember that's what we're looking for. We set the equation of this line equal to this line. Okay, so we set a half x plus 12,5 is equal to negative 2x. Okay, so what we're going to be getting then is, if we go to the calculator, we're going to be getting a half plus 2. So that's just going to be 2,5. X on this side, and then the 12 goes over to the other side as a negative. So it's going to be negative 12,5 divided by our previous answer. Okay, I messed up there. So it should be 2 plus a half. Okay, so on this side, we're going to be having 2,5x. On the other side, negative 12,5. So we're going to say negative 12.5 divided by our previous answer. Okay, so we get x is equal to negative 5. X is equal to negative 5. All right, so then to find the y part of the coordinate, we just say, well, y is equal to minus 2 times 5, which is negative 10. Sorry. As soon as I said negative 10, alarm bells were ringing because I knew my y needed to be positive. So my mistake was there, it needs to be negative 5. Okay, so that is 10. Okay, that's why it's important to check sometimes because little mistakes do happen. So therefore, the coordinates of B is negative 5, 10. That's the coordinate of B. So another way that you could have done it from the memo, or rather the way the memo did it, is they did it like this. So they did this. Okay, so they said, okay, if we move this distance x, then we know that our y is negative 2x. Okay, so it comes from here. Okay, so if we move this distance x, this will be negative 2x, and we know this distance is 125, square root 125. So what they did here yeah, so they did the distance formula, but you could have just done Pythag like this in this triangle down here, and then you would have solved for x, and you would have got x is plus or minus 5, but then obviously this x has to be negative 5, right? So that means that this b is negative 5, and then to find the y, you just plug it in over here. So you can have a look at what the memo did. I don't know, I haven't really seen that before. It's actually quite a solid way to do it, but for me, this inclination thing was something more obvious, okay, because I saw these two lines were intersecting, okay. So yeah, but I do know it was a lot of work, okay. So it's always something to consider how much work it is for the amount of marks, okay, because the memo's way was a lot easier. Yeah, because even if we look back at when I was doing the cosine rule, this took up a lot of time, okay. So yeah, just something to consider. And then speaking of taking up a lot of time, the next question is 8 marks, okay, but it is the final question of the exam, okay. And here we got the coordinates of b of this, and then they also do confirm it here, okay. They say if b is those coordinates is given, determine the area of the trapezium OBEC. So we have this coordinate is negative 5, 10, and we need the area of OBEC, okay, and they tell us that it is a trapezium, okay, it's a trapezium. So you can memorize, well, not so much, well, you can know from theory that, let me just get rid of this, you can know from theory that the formula for the area of a trapezium is half sum of parallel sides times by the height, sides times height of the trapezium, right? But you could have done that, but for me, finding EC, the distance of EC, is maybe a bit tough. Actually, no, finding the distance of EC wouldn't be too difficult, but what I would prefer is, it's kind of easy to work out the area of this triangle, and then we need to try find the area of this triangle. We're going to have to find the area of this triangle as well. Okay, so this isn't a 90-degree triangle, so finding the area is a bit more complicated because we're not really going to know the height. But what we can do is we can use the area rule for a triangle. So if we have this angle and this side length and this side length, then we'll be able to solve the area. But if we look in this triangle, finding the distance OC is kind of going to be a bit tough, okay? But what will be easier is we can know the distance OE, right? Because we already know that the coordinate of E, okay? So we can get the coordinate, well, we know this distance, and we need to try find this angle then, and this distance EC, okay? But the main point is, let's first have a look. So that is a bit confusing, but let's first have a look at the area of this, and then we will tackle the area of this one. Okay, so we know that the coordinate here is minus 5, 10. All right. So we know this distance over here, that's our base, right, is 125, root 125. So we need this distance BE, because that's our height of this triangle, okay? But we know the coordinates of E. We showed that the coordinates of E was this. Okay, so to find the distance BE, we're just going to be using the distance formula, okay? So that's going to be, so I'll write the coordinate here, 0, 12, 5. Okay, not degrees, 12,5. Okay, I'll write it big for us here. So E is the point 0, 12,5. Okay, so what I'm going to do is I'm going to say minus 5 minus 0 squared plus 10 minus 12,5 squared. Okay, this is the distance BE. Okay, and if I put this in my calculator, what I'm going to get is this. So minus 5 squared plus 10 minus 12.5 squared. So if I get that, I get this thing over here. I'm just going to write this. I'm not going to show it rounded. So it's 5 root 5 over 2. Okay, 5 root 5 over 2. So this is 5 root 5 over 2 units. Okay, so I can finally get the area of, so yeah, the area of triangle OBE. So OBE, this triangle. Okay, so the area is a half base times height, and that's a half. My base is this, root 125, and my height is this 5 root 5 over 2 units. Okay, so the area of this triangle, again, we go to the calculator, and I'm going to be saying a half times by 125 root of that times my previous answer, and I get 125 over 4, okay, which is 31,25. So I'm going to leave it not rounded right now. So 31,25 square units. Okay, units squared. Okay, now comes the bigger issue. Okay, the bigger issue is now I need to be working in this triangle over here. So let's see and get everything I can possibly get in this triangle, all the information. Okay, so essentially now we've done the first part. We've got the area of this triangle, and then we're going to add it to this one to find the area of the whole trapezium. Okay, so I need all the information here. So let me say that OE is equal to 12,5 units. Okay, so I have OE is 12,5. So if we look over here, I know that this is 12,5, this distance here. All right, let's see if I can get EC. Let's see if I can get this this distance EC. So to get that distance EC, what can I do? I would need the coordinates of C, right? Okay, so I need the coordinates of C. So C is the point of intersection of this line EC and this line OC. Okay, I already know that this is 2x, so I just need to find the equation of this line. Okay, which is not a problem because I know the gradient of this line is -2, right? So if we go here, I can say that, well, the gradient of EC is equal to the gradient of OB, which is -2, right? And that's because OB is parallel to EC. Okay, so I know what the equation of this line EC is, right? So the equation of line EC, the equation of the line is just going to be y is equal to -2x plus 12,5, right? Because C is the y-intercept, and here's where we cut it at E. Okay, so this is the equation of line EC. Okay, so I'm gonna need a new slide for space. Okay, and what was the equation of line BE? Did we end up getting the equation of line EB? We did. We got it here. Okay, so I don't need that. Sorry, I don't need the equation of line EB, right? I need the equation of this line. Sorry, let's go back here. Okay, the end of this paper's got a bit messy. Okay, so yes, so remember what I need the equation, the coordinates of C. Okay, I just got the equation of EC, of this line EC, and I need to then set it equal to the equation of OC, which is just 2x. Okay, so I'm going to be saying that 2x is equal to my -2x plus plus 12,5. Okay, so I'm setting line EC is equal to line OC. Okay, and when I do that, I get 4x is equal to 12,5. So I'm going to be getting x is equal to, and when I'm going to get 12.5 divided by 4, and that is 25 over 8. I'm going to leave it like that as a fraction, 25 over 8. All right, so that's my x. So that's the x part of C. Then to find the y part, what I do is I say, well, y is equal to 2 times 25 over 8. And then that just gives me, I just take this answer I had before, times by 2 is 25 over 4. 25 over 4. Okay, so now therefore the coordinates of C is this, 25 over 8 and 25 over 4. Okay, I was expecting the coordinates of C to be positive, okay, to be positive. All right, so I have that. So now I have the coordinate of E and the coordinates of C. Okay, so what I'm going to do now is I'm going to say, well, distance EC is equal to, so remember the coordinates of E we've shown is this, 12,5. Okay, so this distance EC is given by this 0 minus 25 over 8 squared plus 12,5 minus 25 over 4 squared. Okay, so when I do that, I get this for EC. I'm just going to put this in my calculator. I'm going to be getting minus 25 over 8, that thing squared, plus 12.5 minus 25 over 4, that thing squared, and I get 25 root 5 over 8. Okay, I'm going to leave it like that. I don't want to round. 25 root 5 over 8 units. Okay, so I got some progress. Okay, I got some progress cooking up over here. I have this distance now. It was what I just calculated at 25 root 5. Okay, so I have this, I need this angle to then get the area of this triangle. Okay, I need that angle because we're doing the area rule. So let's see, how can we find that angle? So actually, these two lines are parallel, right? So these two lines are parallel. This and this are parallel. So what do you notice between this angle and this angle? Right? That angle and that angle are alternate. Okay? And I already worked this out, right? When I did that inclination thing. Right? So I already know what this angle is over here. Okay? So that is very helpful for me. So again, I'm going to need another slide. Okay, long question for 8 marks. So what I'm going to be saying is, where did I work out that angle? Where did I work out angle? I don't even know what I called it. BOE. I called it angle BOE over here. So here's angle BOE. It was 26,6. So this angle is 26,6. So then this one will be also 26,6. Okay. So I'm going to be saying that angle BOE is equal to 26,6 degrees, and I've already proven that before. Okay, so I'm going to be saying that angle BOE is equal to angle, and I'm going to be calling it OEC, this angle over here, OEC, OEC, that angle, and the reason and that's also equal to 26,6 degrees, and the reason there is these parallel lines. So it's alternate angles, right? So we use alternate angles with OB parallel to EC. OB is parallel to EC. Okay, perfect. So now what I can do is I can work in this triangle. I can work in triangle ECO, okay? And I have this side, I have this side, and I have this angle in the middle. So I can use my area rule. So in triangle ECO, okay, ECO over here, ECO, all right, we have that the area is equal to a half, and then this side length over here, which is 12,5, okay, times by this side length, EC. So where did we work out EC? We worked it out here, 25 root 5 over 8, 25 root 5 over 8, times by sine of this angle in between, sine of this angle over here, which we just found is 26,6 degrees. Okay, so we're nearly there, So we put this all together, so it's a half times by 12.5 times by that answer I had in my calculator times by sine 26.6 degrees. And the area of this is 19,6. 19,6. Okay, units square. Okay, but let's not lose focus. Let's not lose focus. Where will they ask? Okay, they want the area of the trapezium. We've worked out the area of this triangle and this one separately. So to find the area of the whole trapezium, we just add them together. Okay, we just add them together. So we say therefore the area of OBEC is equal to 19,6 plus, where was the area of the other triangle? Over here, 31,25. 31,25 units squared, which is equal to, we add these together. So if we add those together, we get 50,9 units. 50,9 units square. Okay, 50,9 units square. Okay. This is slightly different from the memo, okay, because the memo actually gets 50,8 units square. Okay, I think you would get this mark. Okay, wait, never mind. So technically I rounded here. Okay, I shouldn't have rounded here. Okay, because remember in the calculator, I got this, but when I did it on my calculator, I put 19,6, okay, which I shouldn't have done. I should say this answer plus 31.25, and then I'm going to be getting 50,8. Okay, so this answer, they probably, I don't know, I really do hope they would mark it right, but technically I did round there. Okay, so this should be the answer. Okay, so don't round here. Okay, so if you're not comfortable with keeping all this stuff in your calculator, I recommend working to 4 decimal places. Okay, so for example, for this answer over here, write it as 19,5551, I believe it was. Yeah, comma 1. Because even if you do 19.5551 plus 31.25, remember the 31.25 was not rounded, you still get a 50.8. Okay, so if you're not comfortable keeping all that stuff in your calculator, work to 4 decimal places. That would be my suggestion. Okay, so as always, I hope that was helpful. Towards the end, my explanations were maybe a bit messy, and I do encourage you to look at the memo for this past paper, because there were quite a few alternate methods you could have done, and maybe those are easier for you to see than rather what I did. Okay, so yeah, so all the best guys, and thank you for watching.